Is it better if I stand over? Well, good morning and welcome everyone to the Regional Science Consortium 20th Annual Research Symposium, which is pretty impressive. My name is Jen Salem. I am the Plant Lab and Greenhouse Manager here at the Regional Science Consortium. And for those of you that don't know, we are located in this building all the way on the east side in the research wing, and we have a variety of labs located there. We are comprised of 43 member organizations, including colleges and universities and other partners. During this time, when scientific research is more important than ever, we are excited to host the 20th year. So I just think that's so cool. This year we have included 43 oral presentations, 58 poster presentations, and 20 art exhibits, which was a totally new thing for us. And they're all given by graduate and undergraduate students, researchers, artists, and faculty. So we really appreciate your attendance, and if you would like to see more of the symposium, it can be found on our YouTube channel, which is RegSciTV.com. And if you have any questions today, you can find any of us that will be located at the check-in registration table or walking around. And in fact, we have Sean and Sarah. Let's see, okay, in here as our other staff people, and you're welcome to come see us if you have any questions. But I am also your moderator for this first session. And so I'm going to introduce our first presentation of the day. We have Carissa Stone presenting Underwater Archaeological Field Program, Lake Erie, PA, USA. And Chris, I'll have you come up here and give your presentation.
Hi, so my name is Carissa Stone. I attended some classes here in Lake Erie, PA, and at Tom Ridge Environmental Center over the summer. It was from the months of July to August, and I attended the Underwater Archaeological Field School that Dr. Ford, Dr. Halligan, and Adam Burke had ran. So the Lake Erie Underwater Cultural Resource Management Archaeological Field School contained learning information on underwater cultural resource management, also known as CRM, at Lake Erie, PA, as part of a specialized field school that was led by 2 instructors with doctoral degrees and a teaching assistant, which I had already mentioned, Dr. Ford, Dr. Halligan, and assistant Adam Burke. 10 students, including myself, were part of this hands-on experience with scuba-assisted archaeological research and marine survey with side scan sonar and sub-bottom profiling. So what is cultural resource management? So CRM is the legally required management and protection of our shared heritage. CRM requires archaeologists to understand legal frameworks, professional ethics, consultation, and project management. CRM in an underwater environment requires specialized skills in remote sensing, landscape reconstruction, and occasionally scuba diving. Some legal frameworks, if anybody wanted to do this QR code, this has all of the legal frameworks that we did, but the main ones, one that most people are known for is NAGPRA and the National Historic Preservation Act. So the National Historic Preservation Act legislation is intended to preserve historic and archaeological sites in the United States of America. NAGPRA is the Native American Graves Protection and Reparation Act, which provides a process for federal agencies, museums that receive federal funds to repatriate or transfer from their collections certain Native American cultural items to lineal descendants and Indian tribes, Alaska Native corporations, and Native Hawaiian organizations. Some of those cultural items are human remains, funerary objects, sacred objects, and objects of cultural patrimony. So this is the last one I'll show you, which is a big one that we used, which is the Abandoned Shipwreck Act. It's meant to protect historic shipwrecks in the U.S. waters from treasure hunters and authorized salvagers by transferring the title of the wreck to the U.S. state whose water it lies in. So Ethics in Archaeology, Society for American Archaeology, also known as SAA, are the 9 principles, which is stewardship, responsibility, commercialization, public education and outreach, preservation of archaeological record, reporting, training and resources, safe and educational workplace environment, and diversity and inclusion. So the local resources we had was the Tom Ridge Environmental Center, which is the building we are in today, Divers World PA, Osprey Charters, our captain's name was John, and then Lake Erie Adventure Charters, which was with Captain Peter Schaefer. So some underwater recording techniques that we used. We used side scan sonar, also known as SSS, and sub-bottom profilers, SBP, with a towfish. So side scan and sub-bottom profilers are complementary technologies that are often used together in integrated systems to map the ocean floor and reveal what lies beneath. So SSS and SBP, side scan sonar is like a multi-beam echo sounding that it covers a swath of the seafloor, except that a time series of strength of the return signal is measured, not to the time of the first return. SSS can be used for mapping, identifying habitats, detecting objects, and interpreting material. And here's like a little visual example I have on the side here for you guys. So here is some of the side scan and sub-bottom equipment we had. This is Dr. Halligan and Adam Burke putting it together on the boat. And this is our towfish here on the side that gets dragged behind the boat. So the towfish is a platform that holds a transducer array which sends the receive acoustic pulses. The towfish is towed behind a vessel by a cable. Side scan sonar with the towfish is used for a variety of purposes, including mapping shipwrecks and other cultural heritage sites, identifying marine animal habitats, and characterizing the seafloor's composition. And here are some more pictures of us first setting it up. I'm here, right here in the corner. This is when we first tested the towfish and the equipment before we set it up on the boat. So another thing we used here and we learned how to use was a program called SonarWiz. So during our time here at the Tom Ridge Environmental Center, with the help of Dr. Ford, Dr. Halligan, and Adam Burke, we got to learn how to use software like SonarWiz for processing and interpreting sonar data we collected from marine survey with side scan sonar and sub-bottom profiling. So the students worked at alternating shifts between the lab using SonarWiz to go through hours of data pinpointing anomalies that we assume were man-made or represented buried strata, while the other set of students recording the Kenobi, practicing trilateration, and also baseline offset. Our alternating shifts, we were usually on the boat for about 9 hours. So this is our survey area map of Lake Erie that we were in, where we were doing some of the data work, and we were working at in the map of Lake Erie for the Kenobi, and where we were doing just like the sub-bottom profiling side scan sonar. So the SSS and SBP data collected, the data that I'm going to show you is an example of data summaries prepared by the students while reviewing side scan and sub-bottom data. So our process data report for the side scan on 8.1 to 8.5 was processed by Aaron Schrogen and me, which is Cursa Stone. Most of the sub-bottom sand formations and most of the bottom was sand formations and collections of zebra mussels. There were also many anchor drag marks and lines made by fish. There were also a lot of large sticks, tree trunks. There were also many unknown markings that were also flagged. So more of the data that was collected, it consisted of 5 transects covering about 491.434 square meters. The set initially contained 30 files. However, 19 of them were corrupted and removed, and they were our biggest and most needed files. Many of the remaining files were very small, did not provide much helpful information, but they are still included in this set. Each of the larger files, at least 2 strata lines were detected. All of these lines look relatively soft compared to the lake bottom, suggesting there were changes in density. There were a few small spots of highly reflective material in the files of 2802.001, 2802.001, and 282.001. A line of highly reflective material was found in those files, suggesting a change in material at 7 meters below the lake bottom. This is an example of the anchor track marks on the sub-bottom profiling in the SFS that we were doing. This is a picture I took my phone because it was pretty unique and everybody had no idea what it was until the professors were like, it's probably just somebody that was trying to anchor on smooth ground that they couldn't anchor on. So this is some of the SVP data that we pulled. So like your main line at the top, the thicker black line is going to be like the bottom, or sorry, the top of the water, and then the middle is like where the towfish would be at, and then the bottom is what the towfish had picked up. And here is another example. And a lot of these larger pieces at the bottom are like either rocks or something we had pinpointed because we weren't sure what it was. So it was either man-made or an anomaly. We just didn't know what it was for. So moving on to the Kenobi. In 1921, the Kenobi was scuttled due to a severe damage in a storm on Lake Erie. The Kenobi was built in 1887. It was a bulk freighter and was given the name Iron King. Constructed in Detroit, Michigan by Detroit Dock Co., the Iron King spanned 252.4 feet in length and 38 feet in width and 28 feet in depth. So this is where the trilateration and baseline offset comes in. It was another thing we learned and used a lot during our field school at our time here. So trilateration is the process of determining absolute or relative points of measurements of distances using the geometry of circles, spheres, or triangles. It also uses at least 3 different distance measurements between a target and a reference point to estimate the target's position. And baseline offset is when short measurements are taken at right angles to the main survey line to locate a nearby feature or object, which is really good for recording depths and curves. So baseline offset is something that my partner Anya and I chose to use for our measurements of the Kenobi, while others use trilateration or baseline offset as well. The 2 alternating shifts shared a large cut-out piece of mylar, and we pinpointed the areas we took measurements of. And the side 2 pictures are something I had taken pictures of underwater of us doing the baseline offset here on the side. Here, if you guys can see this clearly, is the finished product of the mylar piece of the Kenobi measurements we had taken. Here on the side there's not many like wood pieces because that side of the Kenobi was like exploded when it went down. So there's no front piece there. And then there's some boards at the top and then some debris towards the very top. And by another student who did this finished project, this is what it would look like all together for the Kenobi for us that we had taken the measurements for. So here's like the front of the boat. You have the hull that continues in the back, and then the keelson and the keel, that's everything in the front. And then you have some different types of the floors of the keelson and then the ceiling area. So the acknowledgement I have for this presentation is the Center for Field Sciences, the National Marine Sanctuaries Foundation, the Regional Science Consortium, Indiana University of Pennsylvania, Texas A&M University, the National Oceanic and Atmospheric Administration, Dr. Ford, Dr. Halligan, and Adam Burke. If anybody has any deeper questions or would like to know more about the field school, my email is located at the bottom here.
We do have some time for a few questions.
Yep. If anybody has any questions.
Is this data being shared pretty much across the Great Lakes as well? I mean, is there
Yes.
communication going on with
So everything that we had done, we do have like a entire Dropbox folder of literally like probably 50 different files that we have been sharing between the students. And then Dr. Ford, Halligan, and Adam Burke had shared those with other people. Like the measurements we have of the Kenobi are also being shared with other people since there aren't actual measurements of the Kenobi right now underwater. So those are being shared so people can also do some more photogrammetry of the Kenobi and like photo mosaics so people can see what it looks like at the bottom of the seafloor. So yes, it's being shared between many people. Yes.
You might not know this, but do you know if it's being shared with the past dive team, Pennsylvania Archaeological Shipwreck Survey team?
I'm not sure, but I think Dr. Ford did mention past in passing. So yeah. So you,
Alright.
so I think
They
you guys
cannot,
should.
they'll reach out
Yes.
to me.
Yeah,
But-
definitely reach out to him
Okay.
or reach out to me, and I can let you give you the information that we have.
Okay, thank you.
You're welcome. Anything else? Anybody?
Okay, well, thank you very much. And I think, we're just going to take a tiny little break. Okay. Unless we did tiny break. And, we'll pick back up at 9:55. All right, well, thank you for bearing with us on our little intermission here. We're going to get right back into it. And it's my pleasure to introduce Mike Berlin from WQLN. He is going to present on lake science for idiots.
I'm calling me names. I'm calling me names. Hopefully this all works out because we were having a song and dance trying to get it up there.
Let's just go. Sorry, slipping here.
I'm living up to my title. This is good.
Yeah, well, let's see here. We
It's
should
on
be able-
the picture part. Yeah.
Getting it. Okay.
All right.
All right.
Hey.
I feel like this is going to need some explanation.
Probably. I had one of my coworkers dock up on a that's me with a dunce cap. And so I guarantee you, anybody who's watching or you guys, I'm the dumbest person here today. And so, but I'm here to talk to you on some level of like the idea of what you guys do as a community is incredible. And when I first started Chronicles, this is what I started off with. I'm born and bred in Erie, lived in New York City for 20 years, came back, and I pitched this idea of like, let's do a deep dive, no pun intended, into Erie's history, and let's really try to put some context to things. And the joke I would make is no War of 1812, no pizza bomb. And just because I think those have been sort of exhausted and explained to death. But I came up with this big wall of ideas. And the idea was until I could hire anybody, I had to have 100 ideas, 100 note cards up there. And so I came up with 100 ideas. And then I started going out to sort of partners in the community, like the Regional Science Consortium, the Hagen History Center, the Heritage Room in the Belasco Library, and the Jefferson Society. And pretty quickly I learned it's like, I think what Erie's problem on some level is, well, we're going to get into this. So I apologize. Public speaking is not my thing. Normally I'm behind the camera. So I had to try to figure out what am I ultimately trying to say, or what am I ultimately going to try to do with this television show. So to put some context into things, one of the things I realized being from Erie is that we know our community, but we don't know our history. We're poor at it. We're very poor at it, and we haven't made a priority out of it, ultimately, at the end of the day. And it goes back to 1784, when Andrew Ellicott comes and does the survey, and then 1791, they signed the treaty with the Haudenosaunee tribe. But even that in itself, if you go on probably like Wikipedia or something like that, they're saying something like, they're calling them the Iroquois, which is a derogatory term. And it's like, we have never taken the time to put these things into context. And Presque Isle and the lake matter, ultimately. And I'll get to this in a second, but it's, as Erie's fortune has gone, like the rise of our economy, it's all sort of centered onto the lake on some level. And it's important to put that context into things because honestly, that is where we are going also. The history, we have a saying on the show at Chronicles, we don't say that history repeats itself, but we do say that history rhymes. And there's a lot of things already happening now in 2024 that sort of resonates back to the day of where we were as a sort of an industry hub beforehand. So when I finally was able to sort of put it in perspective of where the Bayfront was and where it is now, the thing that came back to me that Erie needs to start appreciating, and that maybe, just maybe we could do on the show, is the idea ultimately of, if I've queued this up correctly, preservation. It's going to happen there any second now. And so, because I was supposed to keep on talking, and there we go, preservation. Yeah. So, thank you. Seamless. We'll cut this out. So it's preservation. I think it's important for us to start doing a better job of preservation and not to just know the history of the Anglified side of perspectives, but to know the Haudenosaunee, to know the Black culture, to remember that we once had a Portuguese community that was very vibrant down at the docks in the Bayfront. And it's just like we have let so much of this sift through our hands. So this. There we go. So then and now, how did we get here? It's a little bit what I've been talking about. I will play another slide for you real quickly. Serena, let your Enya play and everything like that. So real quick, where I'm going to come with this, my science friends here and partners, and Lake Erie's declared dead. I don't know if you guys remember this. At the time in Life magazine, it's declared dead in the 1960s. The Cuyahoga catches on fire. In 1968, the Land Water Reclamation Act. There's a big movement now, and things start putting teeth to the EPA. Water Pollution Control Act of 1972 starts to affect Erie directly. And they start looking, as they're starting to look around the country, they're starting to recognize that Erie's bayfront is a total and utter disaster. So why this matters? Erie folks mostly being here, and I love us, we focus on football, we focus on politics, we focus on economy. But we never talk about our science. We never talk about the lake. We never talk about the ecology. And that is super important. Like it's like forgetting a part of who we are ultimately at the end of the day. In 1980, a consent decree is declared by Congress. Erie is going to run into a huge budget and financial problem because Congress is going to begin to fine us $5,000 a day. This is toward the tail end of the Lou Tullio administration. I'm not here to necessarily quibble about politics, but Tullio even recognizes there's a great, because I sit through these things, at every budget meeting for the city, they would write out a sort of synopsis beforehand. And towards the end, the thing that Tullio, at the beginning of each budget that he would submit, he is worried about the consent decree because it has the capability of bankrupting the city, which is already bankrupt. We're robbing Peter to pay Paul. This matters because ultimately it's not going to really be, it's going to be a combination of everybody, but it's not going to be the politicians who end up figuring it out. It's going to be you guys. And nobody ever talks about that, but that's one of the things that I start to recognize on the show. That it's like we as a community, if we're talking about preservation, haven't done enough to give credence and to give a spotlight to the scientific community that has always been here. It's super important. In 2000, but it does take a partnership. Savacchio comes in, Tullio's last pretty much advice, it's like you've got to figure out the consent decree. This is all happening out of the limelight of the newspapers. Joyce figures it out. She finds her partners. She gets things in order. In 2008, we celebrate with the mile swim and the idea, and it becomes a sort of a marketing tool with Visit Erie and with all the partnerships that we have a swimmable bay. Now it's complicated on some level. I can also make an argument for the other side, and I've had these conversations at the Plymouth and Calmaris where it's like, Erie's, I get this question all the time. What happened to Erie when people come in from out of town? It's like, oh, why is Erie so depressed and stuff like that? Well, there's a lot of things that happen. One of the tough things for us to sort of stomach on some level is that Erie's population and economic peak are around 1958 to almost 1962. And it does sort of coincide that when the Clean Waters Act happened, we lose some of our industry. But I ask this pretty much of everybody. Would you rather have that industry or would you rather have your bay be a total sludge and mess? And the numbers, the other thing I've looked into is the health records and stuff like that. We were spiking in cancer at that time. So for what it's worth, we don't get to have everything in this world, as much as we like to try. So Lake Erie is the story of Erie. Chronicles, this is where Chronicles comes in. And so our job, if anybody recognizes the gentleman on the right, we filmed that interview in this room. That is Bob Wellington. Bob Wellington deserves a statue somewhere. Bob Wellington is the first person hired by the EPA through Pennsylvania to monitor the water control of our streams, of our lake, and he is out there and he's got some wild stories about showing up to test the water levels of like Zern and people pretty much threatening his life and breaking his windshield and stuff like that. And he's just doing his job as a scientist and trying to make sure that, and Bob's thing was always that he he just wanted his fishing to come back. He was a kid who grew up on the Cascade docks. And it's just like, and he had seen the blue pike leave. And it's just like, okay, somebody has to start getting responsible and start taking action for this. Because preservation isn't just about buildings. It's not just about stories. It's also about our environment. So, real quick. So this is what we make the television show about. And here's a little trailer of Chronicles. Hopefully it doesn't blow out everybody's.
If you don't know WQLN, it's your local PBS station. If you don't know Chronicles, it's our 6-time Emmy-nominated docuseries. Journey through time as we uncover the captivating history of Erie, Pennsylvania and the surrounding region. Meet the pioneers and discover the stories of the unsung heroes whose courage and determination changed the course of history. Chronicles airs Thursdays 8 p.m. on WQLN PBS, or stream all episodes now at WQLNchronicles.com.
So I wanted to share that with you. It does exist. Hold on. Let's see if I can. Come on. There you go. So that's the show. I just wanted to give you a little bit of a taste of it on some level. And update, that's the end of season 1 trailer. In season 2, we got nominated for 22 Emmys, and we actually won one, which is hard to do. Thank you. Anyway, so, but it's like, I appreciate that. And honestly, it's the team. I mean, we are a ragtag group. And one of the things that I tried to do is really try to create an eclectic group. And because I thought if I had a lot of people who just are a guy and they're, like, believe me, there's been a lot of education going on for all of us, but it's just like we needed to diversify how we look at these things. If we try to keep on looking at things the same way, that's the very definition of insanity on some level. And to try to get that perspective for preservation, you have to invite other people who maybe who do not come from your same economic sort of background. You have to invite other people to the conversation, and you have to listen. And so we have age range, demographics. We are all very, 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 very different. And in that process, I'm very proud of what we've come up with and what we've been able to accomplish. So, finding the theme, preservation, that's what it's about. Ultimately, one of the things, and how am I doing on time? Just want to make sure. Okay. So, on season 2, I knew that I really wanted to bring it back to the lake. We had funded a program called Lake Erie Our Kin, they did a great job and sort of really touched upon where things were kind of more now. But I really I felt like one of the things that was missing to connect to the audience was really trying to create that idea. And so people understood the scales that there were between economy and ecology, because that's really been the battle that we've had as a community ever since I've lived here, which is pretty much my entire life. So I did an hour-long program, and I had the first half of that program called Trade on the Lake. I focused on Waterford, because when we sort of drew it back, we kind of saw that a lot of the economic beginning of Erie starts in Waterford, of all places. And then obviously the canal comes through, but they would, like, whether it would be lumber, pulpwood, coal, a lot of that was sort of coming up through the streams of Waterford, and they would get to the lake, and then it would open itself up out to the rest of the world. Because once upon a time, Lake Erie, from Buffalo to Detroit, was the #1 trade route in the entire world. And I don't know if you guys know this, but even to this day, I'm sure it holds true that the Great Lakes region, if you combine it all together, and that includes Toronto, Chicago, Milwaukee, Buffalo, Erie, we are the 3rd largest GDP in the world. So you have to think about the economics of these things. And then, so the first hour of the show, or the first hour of this sort of special with Trade on the Lake, we focused on the economy of it. And then the next hour, we sort of lined it up a little bit, but then we go into the more sciencey side of things, and we talked to spoke to Bob Wellington, spoke to Jeanette Schnars, and who we all know and love, and sort of really presented that skew of things from history. And I really, at a certain point, I did in the second half of that episode, I wanted the audience at home to be aware of the different organizations, whether it's the Sons of Lake Erie, the Fish and Boat Commission, DCNR, PAST, the regional side, I wanted them to be aware of the people who are essentially the stewards of the lake. Because I didn't know when I started. And what's funny is that lake science is totally, particularly the second half of it, is totally different from pretty much everything else that we do on the show. And as I've been going on, that's one of the episodes that seems to be catching people over and over and over, and that they're starting to find online. So, being video, real quick, there we go. This was the episodic that we did for Trade on the Lake.
From the height of the lumber industry to the so-called.
And I apologize if you can't hear that.
With the help of the lake. While the lake today is known for its recreational activities, it was once the beating heart of our commerce, manufacturing, and labor. Chronicles explores the ever-changing role this small strip of shoreline has in our lives and what the future might look like.
Yep. And then let's go to.
We always take a look at the lake and assume the lake has always been there.
We look at the macroinvertebrates and identify them. They can, tell us what kind of fish that they support. They can also tell us about water quality.
Things that were going on 100 years ago or 200 years ago, we didn't know any better. We were stupid.
I love Jerry. So here, real quick. I don't have much time. So one last thing. Obviously, listen. You guys need a platform. You're always going to need a platform because otherwise you're talking into an echo chamber. And we were just talking about the idea of communication. And what's my job and what I sort of took on the responsibility and a little later as I came into the show was I was like, I need to provide not just you, but maybe the architects working on 6th Street or, various members of the Seneca Valley or and up in Salamanca. The job of the show, the responsibility of the show is to give people a platform, including you guys. So in that vein, we try to keep it simple because a lot of people aren't as well read as you are. And at this point, I've had to sort of sit there and sift through a lot of dry reading. We try to keep it relatable for people. We try to keep it entertaining. Sometimes we will make a joke that feels out of tune with the audience, but humor has a way of pulling the audience back into the episode. We have some very, very dry episodes, and I'm not always proud about that, but our responsibility is to try to make sure that we are telling the story fully, the best that we possibly can, and we have to do that a lot of times with 28 minutes of broadcast time. And it's hard because these subjects, the more you dive into it, the more complex and the more intricate that it is. And then you learn to brace imperfection because we have deadlines for television, so we don't always get it right. We try to make sure that we're following the practice that we have 2 to 3 resources for any fact that we put to air, but it's, even if from a creative arts perspective, it's just like you want these things to be pristine and how it was in your mind and stuff like that, but you have to let that go. So if I can leave you with any of these messages as you go out there, because we all have to advocate for ourselves, these are the little bullet points of advice that I would give to you. So does anybody have any questions? Yes?
Have you read Midnight Airing or thought about doing an episode?
Well, yes, I have. It's actually our premiere episode. Yes, it's called Rum Runners. I know David well. I've become very friendly with David. I hope that he gets an opportunity. He has more stories, and he's talked about actually reissuing the book since some of the people are no longer with us. David has incredible stories, and honestly, the show is just a testament to those people who have done the legwork before we did. And David Frew is one of those people who is honestly a hero to the city on some level. Yeah.
Richard Cal owns the house on David.
Richard Cal is also in the episode, and Richard and I grab a beer every once in a while. And if you ever get an opportunity, call Richard. He has a 6 Mile Creek runs on the back of his house, and you can see the bass feeding off of it once in a while. And so yeah, these are amazing people. And bootlegging is that I made that the premiere because that's an interesting inflection point of Erie's history. Any other questions? All right, I cede my time. to Sean. Oh, and don't forget to double check out episodes of Chronicles on WQN.org, or we offer everything in front of the paywall on YouTube. So, thank you.
Thank you. Okay, our last speaker is going to be mosaicing the past photogrammetry with the Pennsylvania Archaeological Shipwreck Survey team. And this presentation is given by our staff member, Sean Dalton. Take it away.
All right. Thank you, Jen. Yes, so as Jen just said, I'm going to be talking about some of the photogrammetry as well as photomosaicing efforts for the coming season for past or the Pennsylvania Archaeology Shipwreck Survey team. So for those of you that don't know, the past dive team was formed in 2015. It's composed of representatives from the Regional Science Consortium here, Divers World, the flagship Niagara League, Indiana University of Pennsylvania, the Pennsylvania Department for Conservation of Natural Resources, Pennsylvania DEP, the Coastal Management Program specifically, as well as the Sons of Lake Erie. So the overall goal of this organization is to identify, survey, and document all shipwrecks in PA waters. For those of you that don't know, there's over 1,500 known shipwrecks in just Pennsylvania's little portion of Lake Erie, and there's many, many more wrecks that we haven't found that we know are out there somewhere. And as was spoken about already at some of the previous presentations that we had this morning, these are significant historical, cultural objects of our heritage and things like that. And currently there's really no protections for those out there. So along with that identification and surveying and documenting, in addition to that, the goal is to develop educational programs, provide dive instruction, as well as ethical practices for how to interact with these shipwrecks themselves, as well as just appreciate the region's maritime history, because as Mike just said, it's everything that Erie is basically. So the past divers themselves are 100% volunteer. There's actually a full past course that is recognized by the Now We Dive certification board. All that is required to become a past diver yourself is a basic open water certification with any dive certification board. And then usually every summer here, actually out of the RSC's research wing, there's about a weekend-long course that's taught between here as well as the Bayfront Maritime Center, where you learn not only the underwater methods for measuring these things and documenting them, but also just about the history of the ships and, you know, what you're actually looking at when you're under the water. So here's some pictures of some of the wrecks that are out in the lake. All of these photos are courtesy of one of our divers, Jeremy Bannister. That being said, I will say that these conditions are extremely nice for some of the things down at the bottom of the lake. They do not often look like this. However, he really has taken some really amazing photography down there. So that brings me to photographic mosaics. When you're trying to take a picture of a shipwreck, oftentimes you don't have much more than 10 to 15 feet of visibility if you're lucky. And they're large, you know. As Carissa mentioned, the Kenobi is over 200 feet long. So that's not going to fit in a single photo that you can float above the shipwreck and take. So a photographic mosaic, the way that it works is it's a composite image made up of a whole bunch of smaller photographs. So this allows you to get that full subject view while also being able to zoom in without losing any of the detail or resolution of those finer photos. So this little diagram that I throw together just kind of gives you a general idea of how that would work if you were taking the photographic mosaic yourself. You basically mow the lawn with your camera. So as you're swimming along those green arrows, you would be taking pictures at regular intervals. And then software is able to stitch those all together into a single image. So I do have a couple photographs of some of the mosaics that, again, Jeremy Bannister was able to create for us. This one being of the Albion shipwreck, and this one here being of the Indiana. So they're pretty impressive once they're all completed and stitched together. And you can kind of see just how valuable it is to be able to study a shipwreck from this, knowing that this is dimensionally accurate as opposed to only having 20 to 30 minutes of bottom time looking at it yourself for maybe, this portion right here. So the next step of that and what we're moving towards next year is photogrammetry. So very similar to a photo mosaic. This is again a composite of multiple images. However, using this method, you're able to actually approximate the three-dimensional structure of that object from the two-dimensional photos. So like I said, just like photo mosaicing, you kind of do a similar lawnmower with a camera, but you have to get all dimensions of the object itself. Video is also really good and can be used to generate photogrammetry models as well. The software is a little bit more bulky than what is used for photo mosaicing. However, just in the same way, an algorithm looks for common overlap in those images and stitches everything together. From that, it uses calculations based on your camera lens, distance, and angle that the things actually are within those frames. And it is able to generate a 3D point cloud from which you can get a full 3D model of a shipwreck from. From there, what's pretty cool is you can then generate 3D prints of the shipwrecks themselves, so you could actually have a scale physical model of that shipwreck. So this is an example of a photogrammetry model of the SK Martin out in Lake Erie. Again, this is courtesy of Jeremy Bannister. And just a couple weeks ago, I actually did get to see the 3D printed model of this, and it's really cool. So another little caveat that's going along with this now, as I'm sure a lot of people have heard around here, in June of 2023, NOAA did announce that it was beginning the process of the designation for a new national marine sanctuary in Lake Erie, adjacent to Pennsylvania. And so the real value of this is that a sanctuary here would enable NOAA to protect the maritime heritage that's actually in the lake here, including all of these shipwrecks. So here is a map just of some of the known shipwrecks around Erie itself. And like I mentioned, there's more that we know out there even than this. So for next year, the goal of the past dive season is to develop 2 to 5 new shipwreck mosaics. And then in addition to that, 1 to 3 photogrammetry models of those shipwrecks themselves. This January, we are past members and RSC team members. We are beginning a week-long photogrammetry crash course to learn everything there is to it from an expert who's actually coming from Japan to teach us. So we're really excited about that. And so in addition to, just adding more information to the cultural significance and understanding of the region's history, these models and things will be contributed to assist with the designation of that marine sanctuary. So with that, I'd just like to thank some of our partners that have been working on this project with us, and I will take any questions. Mike?
Is there any conversation, particularly photogrammetry and 3D modeling and stuff? AI is starting to get used to some of this stuff. Is there any sort of pushback from the scientific community on some level of whether that would concern about the results? And I guess this could be a question for you as well, where it's like, it's the best that we've got, but can you trust the AI model? So, has there been any sort of conversation?
Honestly, I don't know. I don't know. I haven't heard any talk about AI in this field, but I'm sure it's going to come up soon. But personally, I don't know. I don't know if Carissa, you have anything to add to that.
I do. So the last full digital picture I have of Nomi, that was AI generated from our measurements taken actually by a student that was working under Dr. Ford. So there is some conversation finally starting to come up for AI for specific models and data that you're doing.
Has anybody been able to sort of check the AI model and the model taken, whether through the photo mosaics, how much they align with each other?
I'm not sure about the photo mosaics, but I know that the one I have that I presented was pretty aligned correctly.
Yeah,
I heard you say that it was like 100% volunteer timers.
it is.
How do you become a volunteer?
Well, if you got the open water cert, which I know you do, and you know Ben, I would say send Ben a message and he'll tell you when the next class is because he's involved in it every time that we teach. He's one of the instructors for it. So he'd know a lot more information about how to get signed up for it than I would, but I would start there.
Or Dinosaur, she worked with Dinosaur too.
Yeah.
They're the ones, yeah. They run the class as well, like with us, and we're doing the same exact. So thank you. But yeah, so it's just another scuba certification. Once you're certified, you're just part of the volunteer guys and become a launch certified. Some of them are deeper than 60 feet. So,
I think it would be okay.
okay.
It would be my third time for certifications.
Say I just got my deep end, so you're going to very deep ones. It's like we're not, but yeah.
But yeah, Sarah, Mike, and I are all on the team as well. So
Divers,
always happy to have more. All right, thank you.
Thanks, Sean. So this concludes the first session of the day. We'll resume back here at 10:50. I think that's what it says. See those readers.
Sorry, the camera can't see you.
If I don't put my glasses on.
Yeah. Yeah.
right, everyone, hello. Welcome to our second session of the day. We are going to start off strong with 8 years of piping plovers nesting on Gull Point, Presque State Park, with Sarah Sargent.
All right, thank you, Sarah. And I had to pull together a whole bunch of new data in a new way for this talk, so this is different for me, and I might, hopefully I'll be efficient about talking to you about it. As you all know, though, piping plovers have been nesting here since 2017. I assume you all know that, but you definitely all know now because I just told you so. But this is really an exciting thing because it's the population is a. Okay, I don't have the percentage yield. I hope I remember what sequence you. Okay, first of all, yes, Area Bird Observatory. Just to make sure everybody's familiar with the organization, Area Bird Observatory started in 2018. So we've actually only been here 6 years now. And honestly, the data I have starts in 2017. So before EBO started, but that's back when I was with Audubon, Pennsylvania. And some of the same projects that we're doing now under EBO were originally done with Audubon. But we do a whole bunch of different types of field-oriented work to engage people with birds in various ways and trying to foster enthusiasm for birds and conservation through ornithological research and public education and engagement. So, first of all, introduction to piping plovers. This is a really cool little bird, and many of you may have seen them, but they are pretty rare. They're small. Its wingspan says 19 inches. That's actually not that big, and it's mostly wing. Body length from nose to tail, about 7 inches. And they do vary through the year in terms of how they appear. They have a breeding plumage that they come into in the spring and are in during the summer. Then by July, they start going back into the non-breeding plumage. And the difference is that it's fairly subtle, actually, unless you get a really good look at them. The black band on the forehead and the neck fills in as being black in the breeding plumage. The bill becomes orange. More so in males than females. And in the non-breeding plumage, you can see up on the upper right, there's no black band and there's no black forehead. But otherwise, the birds kind of are very sandy colored, and they're really pretty cryptic and hard to see when you're out there. There are 3 populations of piping plovers in North America, and only one of the 3 populations is federally listed on the endangered species list. The other 2 are categorized as threatened, so they're still pretty well protected, but they're not as severely their numbers are not quite as small. So the threatened populations are the East Coast population and the what's called the interior or Northern Great Plains population. And they nest on gravel sandbars and rivers. And so the Great Lakes population, DPS, is a government acronym for distinct population segment. And they are listed that way because that does qualify them to be on the endangered species list, even though they're not a full species in and of themselves. The Great Lakes population is, of course, the one we're interested in here, and it is the federally endangered one. Historically, they really never very numerous because they have such strong habitat requirements, limitations. They only nest on sandy beaches and only around the Great Lakes. And you know how it is around Lake Erie here. There aren't that many beaches around the lake. Their strongholds apparently used to be a lot of them on the north shore of Lake Erie. There's all around upper north Lake Michigan, and lots of other various nooks and crannies where there are sandy beaches. And of course, we're the only place in Pennsylvania. Pennsylvania doesn't have very many sandy beaches that are very big, so Presque was it. But look over in Ohio, there were several spots where they're historically nested there. So the history of their listing, they were finally listed in 1986. At that time, there were actually fewer than 17 pairs known to occur anywhere in the Great Lakes. In 1987, to try to protect them, it was pretty obvious even then, one of the big problems was nest predation. So things coming and eating the nests, or the eggs in the nest, because they nest right on the sand, right out in the open, and anything with a nose can smell them. So coyotes and raccoons, whatever, could just walk up to a nest and eat the eggs. And so by putting fencing around the nests, that was like step number one in trying to at least get the eggs to the hatching point. By 1988, they developed a recovery plan, which was like what needed to be done in order to help the population recover. And finally, in 2001, critical habitat areas were designated. And this is all part of the process that happens once something becomes listed in the Endangered Species Act. And there were 35 units named as critical habitat areas. And of course, one of them was us right here, Presque. The nearest other ones on the southern shore of Lake Erie were Mentor, Ohio, and Maumee, Ohio. And every 5 years, they're supposed to do a revised version of the recovery plan. So that's your Endangered Species Act sort of encapsulated little lesson on what that involves. So here we are at Presque Isle, and the critical habitat area is everything from the lighthouse outwards to Gull Point, wrapping around to that arrow that goes into that bay underneath. So I don't know if I can get my arrow to work here. Whoops, nope, that didn't work. I'm not sure. This one? Oh, the top one. There we go. Yeah. Thank you. So all the way from here, we go all the way around and then all the way over into here. That was the designated critical habitat area. And so for many, many years, we did a lot of patrolling along here and looking for them and hoping they would nest. And it didn't happen, and it didn't happen. And so when I was with Audubon and I had a whole bunch of volunteers helping at different times, we would look and look and look, keep walking up and down the beaches, trying to see if any piping plovers would show up. And a few did, sometimes during migration, but none nested here until, until 2017, but that's the next slide. This is what's happened to the population since 1984, I guess. And I think nope, I didn't. All right, I thought I put some arrows in here. Like I said, they started using exclosures in here. Recovery plan came out. And then they also developed the captive rearing program where they could take eggs from abandoned nests or nests where the parent had been killed and take them and hatch them out and raise them in Michigan. And they developed that program in the early 90s, actually, or mid 90s. And so between the exclosures and the captive rearing program, there were some real strides made in terms of the total overall population. And notice this is numbers of pairs. And so there's a lot of details around number of pairs versus number of nests versus number of chicks fledged, et cetera, but because they're all, the number of pairs isn't always the same as the number of nests. One pair can have multiple nests if the eggs get eaten, for example. They can re-nest. However, they typically don't re-nest if once the chicks hatch and require the parent's attention, they do not re-nest after that. And there does come a point in the season where they will not re-nest. It's just too late. Anyhow, so this is what the population has been doing over the last, 30, 40 years now, I guess. And in 2023, there has been a reestablishment in a number of the historic sites that were designated as critical, but there's still plenty of areas that are not yet reestablished. And I think I think I pointed out that there used to be a whole bunch of sites along the north shore of Lake Erie, and they're not there, and they have not been recolonized. There was one nest in Maumee, oops, got cut off in this picture, a couple of years ago, but only once. And there's been no others in Ohio since then. Still, the stronghold is northern Michigan over there, right? Sleeping Bear Dunes National Seashore is up in that area. There's Manitou Island is a real stronghold. So that's been kind of the core population through the whole decrease and then regrowth. But we can still proudly say we are the only place in Lake Erie that has nesting piping plovers, which of course we're very proud of. And like I mentioned earlier, their big deal is their habitat requirements. They really are very picky, and they'll only nest in certain conditions. They require sparsely vegetated sandy beaches with a pretty long distance, large distance between where the nearest trees are and where the edge of the water is. They need a lot of open space. They don't want to have any woody vegetation anywhere close to the sand where they're going to put their nest. So there's got to be a very wide dune system and it's okay if it has little wetlands in between. They like that. They're eating the invertebrates. And Gull Point, our site here, it basically requires maintenance. We have to keep herbicide in every year. I hate to say it, but that's exactly what happens. And that is maintained through a partnership between DCNR and the Western Pennsylvania Conservancy. Every year there is maintenance of the habitat to keep it from regrowing. All right, I got to go faster now. So our role is to do daily monitoring during the breeding season. We have a contract that Erie Bird Observatory works on, and our role is, what we have to do is check the entire designated critical habitat area. Since this is a government thing, it's got acronyms. So this is the DHCA, and we have to walk through the whole thing and look for any piping plovers. And that includes that whole section from the lighthouse to beach 10, even though we never find any nesting there. But it is still part of the designated habitat area, and someday maybe they will nest there. We'll have to see. We are supposed to also observe their behavior, specifically looking for courtship behavior and any indication that they're going to nest. Once they do start nesting behavior, we need to find their nests. And once they're in the nesting phase, like incubating and raising the chicks, we have to confirm that both adults are still there and still alive. If they're not, the eggs may need to be taken into the captive rearing program. So that's what we do every single day. Okay, here's the first nest. Can you see the birds in this picture? They're kind of cryptic. This is an incubating plover. This is kind of what it looks like through the telescope. And this is actually adult, the mate. This is the very first nest at Presque in 40, 50, I don't know. We don't really know when the last one was, but presumably in the 1950s. So this is what it looked like May 11th, 2017. And of course, we were ecstatic that they were actually nesting. Yeah. But I'm going to summarize now, hopefully more quickly. This is kind of a year-by-year list of how many nests, how many eggs were raised, how many chicks were hatched, how many chicks fledged, and then how many eggs we ended up having to salvage and send over to Michigan. And I should say, this is where, on the very first slide, I was going to point out at the bottom all the partner organizations, and I have it again at the end, that this is not something that Erie Bird Observatory does by itself at all. This is, like I said, it's a government project. Fish and Wildlife Service is involved, the state agencies, the Pennsylvania Game Commission, and a bunch of other agencies, including DCNR here, all collaborate on this project. So when the eggs are sent over to the captive rearing program in Michigan, that is done by the Game Commission, and the Fish and Wildlife Service make that determination, and that they need to go. So this is just a quick summary, and I'm going to dig into some of the details on this. I'm really taking way too long. But I'm going to try to dig into some of the fascinating details. I could talk an hour about the personalities of some of these birds. But just so that you know, there are some conventions. If I list bird band numbers, band combinations, this is kind of the convention we use, and that's the majority of birds in this Great Lakes population have unique color bands combinations on their legs because it is such a small population and every single bird makes a difference. Anybody who sights one of the birds should report where you saw it and what it was doing. And so that's what the color bands are for, so we can recognize individual birds. The chick bands, when we first band a set of chicks, they do not get the full complement of the bands. We just don't have enough combinations, and a lot of the chicks do not make it. So the chicks all get the same combination as each other. So there's 4 chicks per egg, per nest, kind of like killdeer. And they all get the same combination. However, they get a different colored paint dot. There's 4 different colors of paint dots on their orange band for the Great Lakes population. And in later years, there's been this numbered black band that goes on there. It has a 3-digit number on white that can sometimes be seen through a spotting scope, but honestly, the paint dots are easier to identify than the numbers. These are the glory years, and you'll see what I mean after we get to some of this. I don't know why it says 4 down there. All right. These are years where we had 1 nest per year. The male got rebanded into his an adult combination from his chick brood combination. So after, like I said a minute ago, the chick bands have a smaller combination with the dots and the numbers on certain bands. Once they've survived a few years and start reproducing, we like to get to have an adult band combination that's unique, so it's not confused with the other brood mates. And both of these 2 adults got rebanded in that year. The very first year, there actually was a second nest, very short term, but it got washed out. The eggs were rescued and taken to Michigan. The next 3 years in a row, there was a single nest, and they all hatched and produced 4 young. And it was like beautiful. 1 nest, they all survived, they all fledged. It was great. After that, things went a little haywire. And I will say, this is a picture of our breeding male. He was the adult male, this guy right here. And he did a great job, and he was kind of our founding plover, the great patriarch of the Gull Point clan. And however, he got kind of a swollen head. The next year, 2021, he attempted to mate with 4 different females, he did mate with 4 different females, or 3 different females, had 4 different nests. However, there was a shortage of males in the population. 3 different females were vying for his attention, and yes, indeed, he had multiple nests. However, it's critical that each nest have 2 parents attending it for thermoregulation for incubation during the incubation egg period, but also for the first week or so after the chicks hatch, they need thermoregulation. And most of all, they need defense from predators. And if they don't have 2 parents, they will not survive. And that is illustrated just by this year. Anyhow, what ended up happening was only 3 chicks fledged, even though there were all these eggs got laid. Some of them ended up having to go to Michigan, and others, this one was just too late in the season. They'd already closed down the captive rearing programs. It wasn't there anymore, and so we had to just let those ones go. And then these ones got eaten by a possum, even despite the fact that the exposure was there. So he attempted that. That was that was a huge soap opera year, right? Okay, that was 2021. 2022, a similar thing happened, but different. In this case, 2 different females were laying eggs in 1 nest. And again, he was the father. But all 7 of those eggs had to be taken over to the captive rearing program because it was felt that they were not, without the father's attention, he was already tied up with his first nest over here, defending those chicks, and was not able to devote any attention to these potential chicks. So they all got taken. So that was the exciting advance on that next year. And 2023, we had 4 nests in 2023, and you'd think that would be a good thing, but actually it was a terrible thing. It was an awful year. 2 different adults got eaten by predators, including our founding plover. The founding father was eaten by a predator, and ultimately in 2023, we only had 2 wild-fledged chicks that survived. And I won't go into the details on that. Unfortunately, we found a wing of a piping plover, and these are piping plover feathers, and it was likely eaten by a falcon, we believe. By the way, the feathers were plucked off and left, along with several other feathers from other bird species in the same spot, which like a plucking post, which is something that falcons do. So that was a tragic year, even though we had 4 nests. And this is kind of an interesting wrinkle on it. That pair only laid 2 eggs, and you might wonder why. But oops, there it goes. It's because the son was mating with his mother there. So this was a little inbreeding incident that we had. So this is what happens in small populations. There's asymmetry in the sex ratio, which can lead to some things happening. And then sometimes you end up having inbreeding situations where close relatives have young. And I really think the mother was not that interested in her mating with her son, and she refused him. I was watching them with their courtship behavior. She was really trying to ignore him pretty hard. Anyway, they only ended up having 2 eggs. Anyway, 2024, this year just completed, was sort of back to normal. It was great. Okay, I gotta go. And so that's the wrap up. I just wanted to say, our founding mother now we have, and she is continuing. This is my wrap up slide, and I will say there were 27 total wild chicks have been fledged from Presque, and 22 eggs have been sent over the captive rearing program in Michigan. And 3 of the males that did fledge here have come back to reproduce and mate and nest here, and have had well-fledged chicks. So we are contributing to the population here, and but it's a soap opera out there, it really is. And those are the 3 that have returned to contribute further, and these are the partners. And like I said, the Fish and Wildlife Service, Army Corps of Engineer does some of the work, and then Game Commission, DCNR State Parks, and Western Pennsylvania Conservancy. All right, thank you. I bet there's no time.
Oh, maybe at the end. We'll see. The very, very end. All right. We can get the next presentation up here. All right. Up next, we will have Mark Letheby talking to us about the Natural History Museum at the Tom Ridge Environmental Center. Mark. Also, there is a
Okay, yeah. Okay, thanks for coming today. So I am the curator of the Natural History Museum here at the Tom Ridge Environmental Center. And you may or may not be aware that we have a Natural History Museum here because it's secreted down in the basement. It's an off-exhibit facility there, but we have collections of plants and animals from northwestern Pennsylvania and a variety of things down there that are there for scientific and educational purposes. So the facility is owned by the Pennsylvania DCNR, and it's administered by Pennsylvania Sea Grant. And so I am the curator, and so I take care of things down there. And so, can I show my notes on the screen here? Or?
You want me to try to do different mode?
Okay, I thought there was.
It's duplicating the screen, which is why we have it like this.
Okay.
It got all weird before.
All right, that's up. I'll try to remember what I was going to say.
Sorry.
So, yeah, I've tried to document the species that occur on Presque Isle. I wanted to be documenting the biodiversity of the park. That's kind of one of my main focuses of the museum. And so we have collectors that will go out on Presque Isle. Jerry McWilliams is probably our most longstanding volunteer who collects on the park. He's an extraordinary birder and lepidopterist. So he collects butterflies and moths for us. So we have a very thorough collection of the Lepidoptera on the park. My specialty is herpetology. I like reptiles and amphibians. I also do fish. And we have had in the past some dedicated botanists that have contributed to our collections. But in addition to doing our own collections, I've tried to keep kind of track of the historical biodiversity records from the park. So try to get as many scientific literature collected together in an archive and any other records that pertain to the park as far as biodiversity goes. So natural history kind of got ramped up on Presque Isle about 100 years or so ago with about 3 or 4 biologists from the Carnegie Natural History Museum in Pittsburgh. These guys kind of laid the foundations for what we know about the natural history in the park. Otto Jennings is kind of the guru of Presque Isle ecology, and he did a lot of plant surveys back in the early part of the 20th century. Ortman documented the mussels of Presque Isle. W. Clyde Todd did the birds of Western Pennsylvania, including Presque Isle, and Atkinson collected a lot of the reptiles and amphibians from that period in time. Since then, records of natural history studies in the park have been kind of sporadic. There was an ecology lab run by Pitt University for many years up until the 1950s, and then there have been, of course, many studies over the years from local biologists and students that have added to our knowledge of the park's natural history. Things kind of really have gotten ramped up with citizen science projects, especially iNaturalist. So we've had like an explosion of new species records from the park due to that source. So a few years ago, the park was updating its management plan, and they asked me to update the list of species that they had in their management plan at that time. And I looked those over and I realized they're pretty incomplete lists and questionable accuracy on some of those. I think a lot of them were put together with species that were suspected to be on the park or assumed to be on the park just because they're species that are common in the area. But I wanted to provide a list that was actually documented, preferably with voucher specimens. So a voucher specimen is an object that confirms the identity of a species that's been reported. So we have voucher specimens in our collection downstairs. It's something that somebody can re-examine and confirm the identity or disconfirm the identity that was reported. So it doesn't have to be just physical specimens, but it can be photos or audio recordings as well, and other forms of evidence. And of course, a lot of things have not been collected and documented prior to the digital age. Not as much photography done as far as documenting species in that form. So I had to go on a lot of the published literature, going back to like Jennings and his work. So we got things that he observed on the park, the plants, and what the other guys had reported back in those days, and any other literature that I found that reports. And presumably the scientists studying these species identified things correctly. I tried not to include personal observation records, so no matter how trustworthy I think you are, if you say you saw an alligator on Presque Isle, no pick, no proof, right? So I'd rather not use just kind of hearsay records. So I wanted to get things down to species level records only. There may be things that are only identified down to a genus level, but I wanted to try to keep it to the species level. And I included anything that was a free living observation on the park. So it doesn't have to be something that's established on the park. If there was a sighting of some animal that was maybe a released pet, but it appeared to be living on the park and surviving, I would include that. For example, box turtles, I don't think there's a natural population out there. I think they're released pets, but occasionally they turn up on the park. So the lists are not intended to be a list of currently existing species on the park. So I just included everything that's ever been recorded on the park, including things that we know that have been extirpated since they were reported. So there's no bearberry on Presque Isle anymore. There are no eastern hognose snakes. We know those are gone, but they did historically occur there. And I'm only including peninsula records, so I'm not including the Trek property or the Chicolet property, that's informally known as property south of Trek here. It was acquired by the park, even though it's technically part of Presque Isle. But I do include the 500-foot jurisdictional boundary out into Presque Isle Bay and Lake Erie as part of the area that I was accepting records from. So the sources I used were our collections here at Trek, and as many museum records as I could find through online museum portals. The main one being the Global Biodiversity Information Facility, GBIF as it's affectionately known, and other ones like VertNet and the Mid-Atlantic Herbarium Consortium website also aggregates museum records from the Mid-Atlantic region. And as I mentioned, iNaturalist is a really rich source of records nowadays. So I downloaded records from iNaturalist. And how many people here use iNaturalist? You? Great. So if you're familiar with it, you may know that the app will, AI will, on the app will suggest identifications for your photograph and what species you have, which may or may not be correct, but once you post them, then other naturalists can go online and either confirm your ID or give their own identification for the species. So I only wanted to include, I didn't want to, if you have an identification that has been identified by someone else, they call it research grade. I didn't use that as a criteria because sometimes, people just will identify things and they're still wrong. So I would look at the identifier's profile and see if they had expertise in that group. So if somebody had a PhD in gall forming insects, then I would consider that to be a valid record. And then I just had to use my judgment on who qualified as having expertise in that group. But I wanted to make sure that I captured all the records that were legitimately identified and not just necessarily considered a research grade because somebody added an ID. So I also, like I said, wanted to get as much published literature and scientific journals. A lot of the older records are only going to be in papers, and I would include unpublished reports by state agencies or other organizations that were reported to the park. So the current list that I have includes 3,460 species. And you can see that's weighted towards plants and insects. So some of the groups probably, we're not going to add too many more species, like the vertebrates. We will likely add too many more to the amphibians, reptiles, mammals. Although occasionally new species turn up, like we've added river otter to the list of Presque Isle species since they established on the park in the recent years. You can see the plants and insects are the bulk of the records, and even though we got the insects are second in the number of species recorded, they're vastly undercounted. Even though we have lots of records of the butterflies and moths, it's fairly complete. Most of the other groups haven't been studied, and so we ran insect traps this year, and I had a very excellent intern who is an excellent entomologist and has identified probably hundreds of new species for us. Okay, so some of the problems I'm running into in maintaining these lists is not being an expert in botany or entomology. Since I'm compiling lists of species names, unfortunately, if you know how taxonomy works these days, there's constant changes. So some of the lists, I've tried to eliminate as many of the synonyms, and a synonym is like the name for a same species, but it's been changed. So the current name is different from the name that you might find in older literature or an older record. And so I've tried to eliminate those ones that are the same species with a different name as best I could. But like I say, without the expertise in the particular groups, I'm sure there's still some synonyms in the lists. And so even in collections, you're going to have species that have been misidentified. We've experienced that in our museum where we have a specimen, and once somebody with more expertise takes a look at it, they tell us that we've misidentified it, so we got to change our name and our database on that specimen. A good example is just like a week or so ago, I had one of our volunteers who's a good botanist look at a specimen of a grape that was called into question by someone who found that record online in our collection. And so Andrew took a look at it, and he told us that this is definitely not Vitis rupestris, which is actually an endangered species in Pennsylvania. And he says it's actually one of the common grape species. So that's important that we kind of weed those things out, especially if we've got an endangered species, which is on our list, and it's going to be included as part of our flora and fauna on the park. So we want to make sure those kind of records are eliminated. So I'm sure there's a lot of other records that need to be re-examined, and that's why the voucher specimens are important. Otherwise, written records, you can't go back and verify. Some things have questionable localities. There's a record of a spring salamander from 1905 from the park, but the species, as its name implies, lives in springs and streams, and it's almost guaranteed not to have lived on Presque Isle State Park itself on the peninsula. So since this is a 1905 record, I suspect that it was probably captured in one of the streams that flow into Presque Isle Bay. And I think that back in those days, they didn't have GPS units to get coordinates, and maps were probably very general. So they probably said, well, Presque Isle is just Presque Isle Bay and the peninsula. So they used very general localities. So I think that that's probably incorrect as far as the peninsula itself goes. Some species on the list may not be legitimate species. I think some of the older records are things that at the time somebody decided it was a species, but it hasn't been accepted later on. A good example from recent time here is that just this year a paper was published describing a new species of bass from Presque Isle Bay. They called it Micropterus parallelis. They called it the common name, the Presque Isle Bay bass, or Presque Isle bass. Most of the biologists I've talked to don't really accept that that's as a legitimate species. I think it's just a local variant of the largemouth bass. And just to reiterate, these are all historically present species, so a lot of them may not occur anymore, so I don't want to, people may get the impression they see a species list and think, oh, these are all the things that are found on Presque Isle, when actually Many of them are probably extirpated, or they may have been just temporary species like a released pet or something. Okay, so in summary, Presque Isle contains a lot of habitats and species that are rare to uncommon in Pennsylvania, so it's been a very point of interest for biological and ecological research in Pennsylvania. There's a long history of research on biodiversity on Presque Isle, but it's been kind of uneven. So there's a lot of research on birds and plants, but a lot of the other species groups have not been studied very thoroughly at all. So Presque Isle changes through time through various factors, lake level changes, human use, global climate change. So you can expect that there's going to be species that are going to disappear from the park as the habitats change, and you're going to add species through releases of pets and other invasive species that may establish on the park. But we need to know the past and present of biodiversity on the parks to give us a baseline to manage the park's wildlife and to provide a baseline for further study of the ecosystem on Presque Isle. So my ulterior motive in doing this program is to kind of solicit people to help out in maintaining and improving our species lists. I encourage everybody to use iNaturalist. It's really easy. Like I say, you don't have to know about plants and animals to use it because it provides suggestions on identifications, and then other people can correct it if it's incorrect. So it's just, I don't know, some of us are just like kind of passionate about using iNaturalist. It's just a lot of fun. If you do have some expertise, it's great to have people go on and add identifications to the species. If, you know, like I say, I can't be expert in all the different groups, so if I can get other people to look at the records on iNaturalist and confirm them, if they know what they're talking about, I can add those to our list. I'm always looking for other sources. If you know of other papers or other collections that may have records from Presque Isle, please let me know about those. If you're able to look at our lists and identify any duplications or other taxonomic errors, please let me know. And of course, I'm always encouraging people to do more natural history surveys on the park, try to document what we actually have out there. And if you are able to, if you have a permit to do so, I encourage you to collect voucher specimens that you can donate to us at the museum, and they'll live here forever as a document of that observation. And also, again, we need kind of help in determining specimens, so I could definitely use some botanical help. I think we have some errors in our plant collection that need to be corrected, so if you have botanical expertise, that would be great. We're collecting a lot of insects, and if you know we have any entomologists in the crowd that could help us identify insects. So we collected a lot of different insects this year, and we may not be able to identify them all ourselves. And so anyway, before I forget, there's a sign-up sheet on our table out here. That's our table out of outside the room here of our some of our specimens from our collection there. And you can sign up if you'd like to get a spreadsheet copy of the lists that I've compiled, just for your own interest, or if you want to take a look at it and see if you can find anything to add to the list. So it's just doing research on Presque Isle is always full of surprises. So this is a red eft, which is the land stage of an eastern newt, and this is a species that was fairly common on Presque Isle up until the 1970s. My old professor, Don McKinstry, says he used to collect them by the handful out there. But since the 80s, when we did a reptile and amphibian survey, to my knowledge, nobody had seen a red eft or an eastern newt of any stage out on the park. and kind of just figured, well, they've been extirpated from the park. It's been 30, 40 years since anybody saw one. And so I suppose I was the only one that got excited by this because I've been looking for them so long because it's a common species, but we ended up getting this little guy here in one of our insect pitfall traps. And I was just like, it figures, we've done herp surveys for decades here and couldn't come up with one, but I set insect traps and I end up getting that red F that I've been looking for 30, 40 years. And so anyway, that's what I have. I can take any questions.
We have to go right to the next presentation. Thank you,
Okay.
Mark.
Yep.
All right, up next we have Lauren Abbott. She's going to be talking to us about utilizing environmental DNA to assess aquatic diversity at Presque.
Good morning, everyone. My name is Lauren Abbott, and today I'm going to be, as she said, discussing the use of environmental DNA to assess aquatic diversity of several small ponds on the interior of Presque Isle. Over the summer, I had the pleasure of going and sampling these ponds with several professors from my university, Pennsylvania Western University at California. Those professors were Dr. Louise Nicholson, Dr. David Argent, Dr. Robert White, and Dr. William Kimmel, who is retired from teaching but is still active in research. As most of you are aware, Presque Isle is a unique ecosystem full of a diverse collection of habitats, which allows for the establishment of rare species that are not seen anywhere else in the state of Pennsylvania. This makes it a hub for biodiversity and a critical site for the conservation goals within Pennsylvania. The goals of our study were to use eDNA to measure baseline biodiversity among these small ponds located within the interior of the park. To compare eDNA, we would also like to compare eDNA as a sampling method to traditional field surveying techniques. So what is environmental DNA? The E obviously stands for environmental. It is DNA that has been shed by an organism into abiotic aspects of their ecosystem. So for an animal, this could be through urine, feces, saliva, plants, it could be through parts of the plant that have broken off or leaves that they've shed. That DNA can then be isolated from the environmental aspects and sequenced to identify the organisms present. Sampling using eDNA is extremely efficient compared to other sampling techniques. Instead of having somebody spend hours in the field setting up traps or trying to observe organisms or do plant surveys, you can just have somebody go out, collect some samples, and take them back to the lab. Not only is it efficient, it can be extremely cost effective. Because you don't have somebody out in the field for extended periods of times, it's less stressful on wildlife. Additionally, there's no need to capture or recapture any organisms, so you don't stress them out that way either. It can also capture evidence of a rare or elusive species that you may not see with traditional sampling methods. This is a map of the ponds that we did sample. I do want to note that pond 3 in the top right-hand corner, we actually did not get any water samples from. It was almost completely dried up and filled with invasive Phragmites at the time we were sampling in late June. We used a variety of collection techniques, including electrofishing, setting up trap nets, and Dr. White and 2 of his interns did a lot of plant survey data throughout the summer. The top picture is Dr. Argent and a student who was working with named Connor setting up trap nets. The bottom photo is myself collecting pond water to later test for DNA. It is important to note when you're working with DNA that contamination is very easy to get in your sample. So to try to combat that, we did rinse our bottles out several times with pond water, and I'm wearing gloves to prevent any contamination from my own DNA. This is a summary of the plant data that we have found. Anything shaded in green is a plant that was present in the ponds. Those that are not shaded were plants that we were looking for that we did not find in the ponds. The first photo on the top left is of coontail. The second is single pondweed. The third is bladderwort, and the fourth is Richardson's pondweed. As you can see in the table, Richardson's pondweed is not shaded in. It is not a plant that we found within the ponds we were looking for, but we did not find it. This photo taken by Dr. White was from another area in the park. Okay, my table is not showing up, unfortunately, so I don't have the accurate species list, but I can tell you the species that we do have in these photos. The first and probably the most interesting aspect of it is a warmouth, which is an endangered species. We did find 3 individuals in pond 1, which indicates that there could be an isolated population of warmouth in that particular pond. The second photo is of one of Dr. White's interns, Emma, Dr. Argent, and myself electrofishing. The third is a grass pickerel, and the fourth is a collection of bluegills, which has also been cut off, unfortunately. Once we obtain our data, we do take it back to the lab. We filter the samples to isolate the DNA. When we store our samples, our filters, we did use 2 different methods of doing so. We stored them in ethanol as well as RNA later. It does seem that ethanol is a better way of storing your filters. When we ran our reactions later on using the filters stored with RNA later, we didn't get as good of results. From there, you extract the DNA from the filters. We use the modified QIAGEN DN Easy protocol, which is just the kit that you use to extract DNA. From there, we quantify our DNA, which allows us to measure the amount of DNA present in each sample. Then we perform polymerase chain reactions. We send it out for preliminary sequencing, which allows us to determine the dominant species located or within our samples. And we do plan on sending it out for shotgun sequencing later on. The benefit of shotgun sequencing is, like the name suggests, it gives you quite a large spread of what organisms could be present in your sample, which allows us to measure community composition. For anyone unfamiliar with PCR, it may sound familiar. It's how they actually test for COVID. It is a way for us to amplify DNA. So from a single cell in our sample, we can create copies of the DNA present in that cell to get millions of copies, which is what makes eDNA so useful. We then use general and species-specific primers. Now, all a primer is a short sequence of DNA that you use during PCR that will target a specific portion of the DNA that you're running against. The first reactions that we did were with general primers to ensure the quality of our DNA. DNA must be sufficiently pure and free from environmental contaminants to be able to run successful PCR. In the future, we plan on running reactions with more species-specific primers and positive controls to look for individual target species. This is a representative set of some of the gels that we did run using our general primers. We used primers that were specifically looking for fish, plants, and bacteria. The bright bands that you can see underneath the wells, and even those faint bands that you can see here, are indications of DNA present for those primers that we were using. The long strings of bands that you can see are what we were running it against. It's a DNA ladder, which allows for us to kind of measure the size of our bands. It acts like a ruler. From our preliminary sequencing results, we got 2 major species, the first of which, unsurprisingly, is common duckweed, which anyone familiar with any ponds of Presque or any aquatic ecosystems in Pennsylvania will know that while it's not an invasive species, it is fairly prolific and can grow out of control quite quickly. The second species we got were Asian clams, which are an invasive species in Pennsylvania. We did get them using primers that were geared more towards fish. However, this just indicates that the DNA in our sample has enough similarities to the target sequence in fish that it was able to pick up the clams as well, although we weren't quite expecting that. This is an example of using a more specific primer. We were looking specifically for turtle DNA, so this is much more taxon specific. That top band in the circle indicates the presence of turtle DNA, and this was taken from pond 7. This is unsurprising because we found physical evidence of turtles being present in the park through a nest and this wonderful little cutie smiling for the camera. While eDNA is a great way of measuring biodiversity and what is present in your sample, there are limitations. For example, analysis can't distinguish between older and newer DNA. So if you're looking for a time-specific snapshot of what is in your ecosystem, eDNA might not be the best effective tool. Since DNA is such a biologically stable molecule, it does tend to stick around in the environment for quite some time. Additionally, if something is just migrating through your habitat, it can leave behind traces that could skew your sample. You're also limited by what is present in what you actually collect. So say you have quite a large pond and the northern edge is completely overtaken by Phragmites, but the southern edge is untouched. If you only sample from the southern edge, you could miss that entire species. So repeated sampling in multiple locations is encouraged. Finally, species-specific primers can be difficult to find or create. Creating them necessarily isn't the biggest problem. It's more proving that that primer is species-specific, that it won't pick up on similar species or other common species in that taxon. We hope to use this data moving forward to allow for continued monitoring of community composition within the park, aid in the control of invasive species, and allow for the recognition and conservation of native species of interest. In the future, we hope to continue collecting additional samples and to account for seasonal variation between the ponds. We would like to use more species-specific PCR for species of particular interest. As I mentioned earlier, we do plan on sending it out for shotgun sequencing. And we would also like to use different statistical analyses and measures of biodiversity to measure the differences between ponds and across time. I'd like to thank again the professors that allowed me to conduct this research, as well as the students that helped out for other projects that they were working on. Connor Haskins, Emma Burkett, and Joshua Ernst, as well as Pennsylvania Western University for allowing me to do this. Thank you all for your time, and I can answer any questions that you may have. Yeah.
So other than Phragmites and the species that you presented, what invasive species are most harmful to your research overall, and what can we as like regular citizens do to help out?
That's a great question. So the species that we did identify with the preliminary sequencing was duckweed, which is not invasive. Phragmites is probably the biggest problem. There's also a lot of narrowleaf cattail present within the park. Those are probably the two main ones I can think of. I know purple loosestrife is pretty much eradicated in the park. So as far as I know, I could be wrong. I think Dr. White is about to correct me, actually.
I didn't hear everything you said. Just to clarify, cattail is narrowly, hybrid, hydro, we think they're looking at stuff. So you have rainwater milfoil, you've got. We have quite a few invasive versions in ponds. But I need all your questions.
I just asked about like invasive species in general, what's the most harmful, and like, what we can do about it.
Yeah, see.
Any other questions? All right, thank you. Thank you.
Right, and then for our final talk of this session for today before lunch, I know everyone's getting angry, but for our final talk of this session, we have Lynn Beatty from Penn State Erie talking to us about a trail of trouble. Thank you. Here, I'd let you present it as you wished.
I'm afraid I don't have any more like ominous voices to use for it. So hi everyone, I'm a faculty member at Penn State Barron, and I'm going to be presenting some of the work that my colleagues Adam Simpson, Sam Newtile, and a whole herd of students and I have done on invasive snails. So we know that aquatic invasive species are one of the biggest threats to freshwater biodiversity worldwide. And these threats can be especially troublesome, or a problem, depending on how you're feeling, if we're dealing with species that are not especially charismatic or ones that people are not especially familiar with. So that is where our invasive snails fall. So the invasive snails, or one of the invasive snails that we work with, are invasive mystery snails. So these are large ovoviviparous generalists. So they can filter feed, they can rasp, and they get almost twice the size of all of our native species of snail. So most of these guys originated over in Asia. They are believed to have been introduced to the United States, at least the West Coast, in the late 1800s, primarily for food. So they were present in food markets. You can imagine if you have a snail, about this big, that's pretty meaty, pretty tasty. They got over here in the 1930s, 1940s or so, being introduced as food for channel catfish. So people believed that they would really help augment the channel cat populations, so they brought them over. There is some belief that they are aquarium releases as well, but I'm not quite sure the relative abundance of those individuals in the populations. And they are first reported on Presque Isle and Thompson Bay in 2006. We know that they were here much before that, though. I've talked to some of the folks that live in the houseboats, and they remember seeing them as early as the 1980s or so. So odds are they've been here a bit longer than they've been reported, which goes back to Mark's species list issue. Not sure when was here, what was here when. So even though they've been here for a bit, we're still trying to figure out what some of their impacts might be, since we don't really know what things were before. That's a little tough. So we do know, however, that they do outcompete native species of snail. Ram's horn snail in particular don't fare particularly well against invasive mystery snails. They are known to transmit parasites. You also know if you're dealing with a snail that is that large compared to native snails, you probably have a change in parasite-host dynamics because of the difference in size and longevity. So these guys can also live 3 to 5 years or longer, depends on which source you're reading. And we also know from some of our preliminary work that they accumulate contaminants, especially heavy metals. So they're particularly good at accumulating copper. They also transmit copper maternally to offspring. So it's a transgenerational transference of copper. So not only do they impact snails or other snails, they can also compete with other native herbivores. So there was a study that just came out last year that found that the presence of these snails can negatively impact tadpoles and the like. So before we figure out exactly what their impacts might be, we need some basic information, because there's a lot we don't know. Again, when we deal with species that are traditionally non-charismatic, or viewed as not as charismatic as others, we're missing a lot of the baseline information. So what we wanted to do is to figure out how many snails are there on Presque Isle, so get a population size estimate, and we wanted to figure out how are they moving around. So we know these guys are invasive. If we're finding them in new locations, is it because they're going there, or is someone moving there? So we're trying to look at our natural movement patterns to try to elucidate what's happening. So we focused our study on 5 different locations in Presque Isle. So Feather Platform is what we call the area over by Leo's Landing. Lily Pond is the pond right by the ranger station. The bridge that, I'm totally blanking on the road name. It's the road that goes over the lagoons. No one knows. It's fine. But you guys know the bridge that everyone drives over. Yes. Graveyard Pond, which is right where the boat launch is, where you can rent out boats, and then Thompson Bay up there in the corner, where again, they were first reported in 2006. So at each of these locations, we established a number of transects. The number of transects that we had at each location varied based on accessibility and just general space there. So at Feather, we had 5. Lily Pond, we had 7. Thompson Bay, we had 15 on both sides of the bay there. Around the bridge, we set up 5. And I will say, for the bridge area, we started monitoring this in this past summer, 2024. The other locations we started in 2022. So we have less data for the bridge population than we do elsewhere because we didn't find them at the bridge before, and now they're there. But anyway, Graveyard Pond, we have 5 different transects. So these transects that we established are 1 by 10 meters. So we usually start on either end. We have people on either end. They search the end meter for a little bit longer to look for smaller species besides these guys. And then we kind of come together, essentially being little water raccoons, where you feel around and you try to find the Easter egg, the snails, underneath you. We did call it going into raccoon mode. So what we would do is we have these established transects. We would visit them 4 days in a row for a week, and then we did this 3 days throughout the summer. So we're looking at 12 sampling days per summer, and for 4 of the 5 locations, it's 2022 to 2024. For the bridge, it's just 2024. Every time we found a snail, we tagged it. So we went through a couple of different iterations of tagging. The most successful that we found was to use bee tags, so like that they would use on queen bees, and then we covered them in UV setting glue. So UV setting glue sets really nice on a sunny day, sometimes too fast on a sunny day, but it does end up transparent, which works for us. They come in a variety of colors, a variety of numbers. The one in the middle here is, there we go, is red 199. So we have a unique color number combination. We did for a bit also use paint marks when the tags were back ordered and we couldn't get them, and they persisted for a goodly amount. So you can also see snail growth in some of these as well. And then we eventually ran out of bee tags, ran out of unique bee tags. So we ended up doing a combination of bee tag and gel UV setting nail polish. So there's a bunch of different colors of nail polish that sets with the sun, and we can put that on there and then cover that all in the UV glue, stays on there perfectly fine. So since 2022, we have tagged 3,082 snails all in the park. So we took this data, we know where those snails were tagged, we know when those snails were tagged, we know when we found them again, and we used that to look at movement and to get population size estimates. Unfortunately, for both you and me, the models didn't run for the population size estimates. So I was running into some convergence issues, which I think has to do with the fact that we have 3 years of data and some things that maybe not be living 3 years, so it's overestimating survival. So it was giving me incredibly low estimates that I have to work out, but I will, and I will get it to you at some point, right? It was telling me like the bridge has 19 snails. No, we tagged like 200 over there. What do you mean there's only 19 snails? So we're gonna put a pause on this for a second and just focus on movement, because that for sure I can show you. So what I have a series of maps here. The first map that I have to introduce you to what these are gonna be like is all of our main 5 locations. So you can see them indicated on the map. And then I have numbers next to each location. The numbers represent the probability of recapturing a snail at that location or at another location. So for our ones that circle back here, that means that's the probability if we tagged a snail in Thompson Bay that we recaptured it in Thompson Bay. If we have arrows between locations, that's movement between locations. So probability that a snail captured, say in Thompson Bay, was recaptured in Lily Pond. And I've color-coded the numbers just to make it a little bit easier to see the magnitude of it. But you'll notice one thing is that most of our locations have a probability of essentially 1. In other words, snails do not move, for the most part, between locations on the park. So those that are found in Thompson Bay tend to stay in Thompson Bay. Those that are found in Lily Pond tend to stay in Lily Pond, which is pretty good, right? They're not doing mass movements around. We do have a couple of real extreme movements, though. And actually, each of these lines is one individual. So we have one individual that we tagged at Feather that was found at Lily, one individual we tagged at Lily that was found at Thompson, one individual tagged at Thompson found at Lily. One of them, the one from Lily to Thompson, was 2023. The other 2 were from this past summer. So we tagged them earlier this summer. We found them later this summer on the other side of the park, which is probably not them moving on their own, which may indicate that we have human-facilitated movement of this species throughout the park. And you'll see that as I look at each of these zoomed in locations, because many of these locations where they were initially tagged and then moved to are at locations that are easy for people to access. So let me show you within each location. Oh, sick, all the numbers are not aligned. Anyway, so I had all of these really nicely numbered. These white bars represent where approximately each of our transects are. So we see our 5 transects here at Feather Point. We again have the circles going around and movement. So you can see, even over a small scale, so I'm sure many of you have walked this stretch before, that is not a long distance. We're talking maybe like 50 feet between some of these transects, and we have probabilities upwards of 0.9 between them. So a snail captured down here is only refound down here. It's not moving far. Although we do have a little bit of movement towards the end, kinda. And then you can see our one individual that ended up in Lily Pond was tagged in this particular transect, which is right about where the path ends. So someone goes to the end, they pick it up, they realize it's alive, they dump it someplace else. It's my guess. Here's Lily Pond. Lily Pond is a little bit more of a hodgepodge of movement, but you'll still note that all of those values are red, so they're all still small probabilities of recaptures someplace else. So even though we have movement all around, it's still many of them do not move all of that far. You'll also note here's where our one that was tagged at Feather was dropped off. Again, here's our parking lot. Oh, look, there it was recaptured. So someone probably was like, oops, chuck it in. One from Thompson Bay ended up over here, and this one's a mystery to me. One from over by the road ended up on essentially the beach side of Thompson Bay. So, but odds are it didn't get there by itself. Right? You don't see them moving all that far. All right, here's the bridge. You can see, again, they don't move. This is one side of the bridge to the other side of the bridge. We have no movement from one side of the bridge to the other side of the bridge. There is this 50% between. That's because we found two snails right there, and one stayed and one left. So it's a sampling bias making that number artificially high. But many of them, I mean, these transects were seconds apart from each other. They're not moving between them. Graveyard Pond, we have a little bit more movement. The population at Graveyard Pond is smaller on the whole than a lot of other locations. We often struggle to find many snails at this location, which isn't necessarily a bad thing. But what I'd like to note is most of the movement we see is out of the lagoons. So there may be a bit of assisted movement of these snails between transect locations if they're going with water flow or something like that. You'll also see over here, there's nothing because up until this past summer, we didn't find any right there. We found, I think, 2 there this summer, and then we didn't find them again. But they may be spreading in some capacity a little bit more that way. Thompson Bay is a mess. But I think importantly, so we have a cluster of 5 transects over here, a cluster of 5 transects up in the corner, and then we have 5 kind of along this point under the osprey that you can really piss off. There isn't movement across the bay. I mean, if we don't have movement between transects, odds are we're not going to make this jump either, but we do not have movement across the bay. The one that we found in Lily Pond from Thompson came from over here. The one that moved from Lily Pond to Thompson Bay was dumped over here. So maybe a kayaker? I don't know, because I don't know if you guys have ever tried to walk this stretch, but you're usually at least to your knee in mud by here. So someone had to really want to put that snail right there and or be in a vessel in order to get there. So a couple other interesting things before I move on from this. So see how close these transects are up in this upper corner? That's literally like 10 meters. Then we don't look for 10 meters. Then we have another transect, then 10 meters. Look at those recapture probabilities, 0.92 and 0.97. So we're talking 10 meters apart, and you have a 97% chance of recapturing the same snail in the same 10-meter stretch. They're not really moving to those other ones that are right next to each other, even though that area is really still nothing else happening. So a little bit of movement up in there. But again, most of the time, they are found in the exact same transect we tagged them in. Even years later, some of the ones that we tagged in 2022 or 2023, we find in the exact same transect. So if this species is moving, it is probably not them. The one thing I'll note, you see this big movement here, where it's again 50% stay, 50% go? That's again because we found 2 snails here. One was recaptured there, the other down here. So it looks artificially large just because of sample size. Okay, So we're hoping to continue this to try to get a little bit more information about population size should the models converge. We can also get more information about movement, because right now we're seeing, like I said, we saw one individual move between locations in 2023, 2 individuals move between locations in 2024. Is this an increasing trend, or is it just happen to be 1 then 2? So we'll get a better idea for that. We also marked a number of individuals for growth this past year. So we put a yellow line right at the opening of the aperture, so that way we could keep track of it, because we're trying to understand a bit about growth and age structure of these populations. Just for a comparison, so this one we tagged here, it didn't grow anymore. I can show you these later if you can't see it in these lights anyway. But this one, which I just found the other day, we marked as a juvenile. So we put the growth line up here earlier this summer, which means it grew this much in a summer. So we're learning, we're doing better. And we still have a lot to go to kind of understand some of the basic biology of these populations. We're also doing some genetics work on these populations to try to resolve species identity. Perhaps we can look at or figure out where they were first introduced, look at invasion pathways, just looking at genetic similarity or population structure. Maybe it'll highlight something that we're not getting with our movement data as far as like where snails are going, because our recapture probabilities are quite low. It's something like 5% of them are recaptured. And the other thing that I'm thinking of maybe doing in the future, so Sean Hartzell, for those of you that know Sean, sent me this paper that he and a colleague published earlier this year on using funnel traps for mystery snails. I guess if you open up the mouth a little bit of it and put essentially like cat food or whatever in it, they'll go in. But I think there's opportunity to try different baits, different positions, all sorts of things, because perhaps that might be a more efficient way to at least augment our recapture rates than our transect-based sampling. But that's something we need to try to figure out. This was also done on the eastern side of the state, so who knows if it's going to work over here and the like. All right, so I would be remiss if I didn't acknowledge our funders, Penn State Sea Grant, Regional Science Consortium, for allowing me to present today, a whole slew of people that helped out with this over the past couple years, my permits, people allowing me to do things. And with that, I will take any questions, and I want to acknowledge this is our 2024 field crew. So it takes an army, and we had one, and we're really fortunate to have them. All right, question? Yeah.
I've never had to do the borders, because I bet there's a lot of foodie and Chinese tourists that be having on the other days.
We have had people ask us. I wouldn't recommend eating them. Yeah, I mean, we don't know for sure what parasites they're hosting, but we do know they are harboring those heavy metals at a minimum that I don't think people should be consuming. So, yeah.
So I know that you guys are doing a great job and putting a lot of effort into tracking these and according to growth rates. After, I guess, adequate data is collected, is elimination the goal because they're invasive, or containment? What are we trying to do about?
I think elimination would be tough since they are established and have been for quite some time. At this point, it doesn't seem, I mean, it's hard to tell what the negative impacts are on Presque Isle specifically since they've been there for that long. We don't know what to compare it to. So I think a next step might be exposure type things and then see what changes as a result. And then we'd be like, are they actually harming anything? If they're not, they're here now. It would be really difficult to remove them all. They do have separate sexes, but the females pop out little live crawling young. So if you have a graphic female, okay. Yeah.
When I have these snails in my fish tank, sometimes they float.
Mm-hmm.
Do you see that in the ponds? Do they do that same behavior? And could that be some of the kind of directional dispersal, like along the bridge that you saw there, where they all kind of look the same way?
Yeah, I haven't seen it. I know they do go on floating vegetation, especially juveniles. So if they're on that vegetation, the vegetation moves. I haven't directly observed the floating behavior from them, no. It could be. Yeah.
Are there any predators that you, yeah, what eats them?
Raccoons.
Raccoons.
Yeah, especially like that backside of Thompson Bay where all the transects are next to each other. Sometimes we'll go back and there'd just be like a pile of broken shells and little raccoon prints there. And I'm like, well, we tagged that one. I guess we know it's fate. But yeah, there's just like shreds of shell back there. Yeah. Mostly their little hands. Just fair. Raccoons all around. Yeah, Kelly.
Could you just clarify again that those probabilities are, I thought at the end you said the recapture rates are low, but I don't understand how the probabilities are like 1 for the movie kit.
So it's 1, because that's assuming recapture.
Okay.
Yeah, so if they're recaptured, where are they recaptured? But our recapture rates on the whole are quite low.
So what are like the recapture rates on the whole?
Between 5 and 8%.
Okay.
But since we've tagged 3,000, we have a good number of recaptures. And there are certainly some that are more or less track happy. Like we have some individuals that we've captured every year since 2022. So like 6 times or something like that. And most of them, though, we never see again. But I don't know where they're going because they're not going 10 meters to the left, apparently. Yeah.
Do you know if there's any major predators land or aquatic on Presque Isle that are using these as like a primary food source or even secondary one?
I don't know about primary or secondary. The only evidence I've seen of is raccoons. That doesn't mean the other ones aren't eating them, and I'm not sure what proportion of their diet is them. It seems like they'd be real easy to get, though. They hang out in the shallows. They don't move very fast. If you can break the shell, sick, like that's a bunch of meat right there. So it could be, but I do not know if anyone has that as a large proportion of their diet.
Any other questions?
Have lunch.
All right, thank you. All right, there is lunch out there, and we will come back at 1 for the third session today. All right, thank you.
Yeah. Yeah. Yeah.
All right, everybody, we're going to go ahead and get started with our third session for today. I'm Sean Dalton. I'm the lab and field manager here for the RSC. I will be chairing this session. We're going to get things started off with living bank stabilization on the wild and scenic Clarion River.
Thank you, Sean. Hold on here. Let me restart the timer. There we go. Okay, cool. Keep myself on time here. Hey, I'm Luke Bobnar. I'm a watershed projects manager for Western Pennsylvania Conservancy, and I'm here today to tell you about a really cool project we did this summer. It's not in the research realm, but it's kind of a little bit novel, and it's also not often you hear about a project going on in a wild and scenic river. So, thought it might fit, and here I am. If you're not familiar with the Conservancy, we're a regional nonprofit based out of Pittsburgh. We've got several different departments, branches. Our land program helps protect land in perpetuity. I work for the Watershed Conservation Program. We do research, restoration, bank stabilization, stuff like that. We have staff in the Natural Heritage Program, helping to keep track of our rare, threatened, and endangered species across the state. If you've driven around Western Pennsylvania, you've seen gardens, in many of the cities and communities, especially down around Pittsburgh. That's also our Gardens and Green Spaces program. And then if you're ever down in Fayette County, you can go see Falling Water. It's pretty cool if you've never checked it out. But the company spiel over. Let's talk about the project. I was lucky enough to work on the Clarion River this summer at Clear Creek State Park. It's a rough idea of where it is if you haven't been there. The park is kind of the valley of the Clear Creek stream. Flow is from right to left on Clear Creek, and then it makes the confluence with Clear Creek right down in our project area. And we had been contacted by the park in 2015 or so. Park staff said, hey, we have a bank erosion issue. It's right on the Clarion. It's wild and scenic right there. And what can we do about it? If you guys haven't heard of the Wild and Scenic Rivers Program, it was an act passed by Congress in 1968 that helped protect free-flowing rivers. America was kind of moving out of that putting dams everywhere phase, and we thought, hey, let's help preserve some of the wilder and free-flowing ones. And we did that through an act of Congress, which is awesome. And we were like, no flow modification to deflection, and they're thinking like irrigation and dams primarily. But it turns out like it's real tough to do anything in a wild and scenic river that's not like recreating. Still, super happy and honored to be able to work, on the Clarion. And we do bank stabilization, we do GP1 fish habitat type stuff. None of that, and especially riprap, is not applicable on a wild and scenic river. And talking to the park staff, they're like, yeah, we lose like 3-4 feet a year, and everybody says that. But actually, they weren't blowing smoke at all. It averages right around 3.5 to 4 feet a year, as proven by aerial imagery. The Clarion Wild and Scenic River is administered by the USDA Forest Service in the form of the Allegheny National Forest. That part of the river actually forms its southern boundary, and so they're the appropriate federal agency to manage it. We have a great working relationship with them, and talking to the park, talking to the forest, it's like, wow, this is kind of out of my wheelhouse. We need help. So talk to folks at DEP, people at Army Corps of Engineers, and also the Region 9 of the Forest Service, the kind of stream guru, geomorphologist. His name is Bob Gubernick. And he said, what you ought to do is figure out what's going wrong. Obviously, you lost 60 feet in 15 years. There's something going on there, and maybe we can make a case for not just stopping the bleeding, but some active management there. So within our project reach, it's about 1,500 feet long. We saw 3 primary things that were impacting or exacerbating the rate of erosion there. Number one, you've seen it in a few pictures here. It's mowing right to the stream bank. The grass has short roots and it's very easy to erode. The Clarion is a big, powerful river. It ate that stuff for lunch, dinner, breakfast, and midnight snacks. Secondly, I don't know how long these culverts have been in place on Clear Creek, but they've been there for decades. And they alter the flow and just the substrate transport out of Clear Creek. So in a normal stream, all that stuff is, rocks, sand, gravel, boulders, they're all tumbling downstream. When you put an undersized road crossing in, it stops them all. And also, they create a little bit of a fire hose effect that shoots out of Clear Creek right there, and it makes the Clarion, as it's carrying its stuff, the Clarion kind of goes, and it drops all the stuff it's carrying, making these islands right there. Also, it is a very well-loved park. You can see that people like to go out and play in the river while they're there using it, which is awesome, connect people to nature. But when they make a rock vein that directs water at the bank, it's not so awesome. So we talked about, let's mitigate those things, and we're still working towards, getting that culvert replaced. But we came up with kind of a conceptual design on working to do a little bit of, try to put in some log jams that might go 10 to 15 feet out into flow and help bump it away from the bank, and then follow that with tow wood and soil brush lifts that we'll get into here. And my thanks again to Bob Gubernick for giving me a lot of direction and insight on this project, and designs and drawings. Just kind of a conceptual design of what a log jam for that might look like. And then following that with the tow wood. And specifically, this is what we're most concerned about. The way we installed all of this was to dig a big bench down. The trees that we use are 20 to 25 feet long, so we need kind of like a big bench, and put in scour protection in the form of these scour logs. Now that's a pyramid of logs that in our primary area, right here, this is the primary area that I'm going to talk about today. It's like 400 plus feet long. We have a contiguous section of that scour log pyramid under the bed so that the river can't cut the toe and then make it slump. So those are there protecting it. And these are just edging out into flow just a wee little bit to help push flow off of the bank. Towards the back of them, we have this longitudinal dead man anchor. And then, of course, our soil and brush lifts on top, which you start out with this bench in the top left. You lay your coir fabric down with a form. You wrap it back over, stake it in place, put your live native brush there, willows, dogwoods, 9-bark, sycamore. Put another lift on top of it, and then grade down. You could make a whole bunch of these, but our bank was about 6 feet tall there, and it was contributing over 300 tons of sediment annually to the river. Pretty nuts. I'm going to walk you through construction here. So, oh, nuts. Well, you still see, it was really cool, the synchronized excavators. We thought, okay, let's dig down, let's dig this bench down, right? And we'll be able to, we weren't supposed to go into flow. Wild and scenic rivers, pretty much thou shalt not. And that was every bit of our intention. And thinking, hey, there should be relic stream channel at the very bottom. It'll be super stable. We'll be just fine. Wrong. It was real wet and sloppy. We almost got one machine stuck and did get the other machine stuck. And then we had to get them out. And then I had a 400-foot long, 15-foot wide gaping gash on the side of the beautiful wild and scenic Clarion River. And I've just done it. And how am I going to fix it? Well, phone calls and communication. And they said, hey, you have the permit. If you absolutely must, you can take some machines in, keep your impacts minimal. That's what we did. And we were able to have one machine down in and one machine up top feeding material. This is that log pyramid of scour logs that we created. They're all tacked together with rebar. We work with rebar a lot for our GP1 fish habitat projects. If I had my druthers again, I think I'm going to learn cable because it was a lot of tacking there. But anyways, there's that getting ready to go in. And then our root wads are going in on top of it. You can see that scour logs are in the trench leading the whole way up there, and the mouth of Clear Creek is right there. So we've got our root wads going in, and then our dead man anchors on the back side of them. And you can see we angle them up into flow just a little bit. And this is eventually going to be covered with like 4 to 6 feet of soil. Plus, there's a former park employee that had a bunch of stone stockpiled on his farm because PennDOT didn't need it after a bridge job. And he's like, you can have it, 400 ton of stone, free. Awesome. Love it, right? Be kind, be positive, be nice to people. So we did that the whole way up there. Did our scour logs in the trench, then did the root balls, the dead man behind them, filling them up with that stone from Scotty Johns. Thank you again, Scott. And then that let our machines run there, and we were, even less impactful to the stream. And we worked our way up to just downstream of Clear Creek for that tributary junction jam to help push Clear Creek out a little bit further and create a sediment shadow behind it where, things should naturally be dropping out. There's even a log under here with its root ball back in here. That is kind of the base of the jam. These root balls face upstream. There's more that are tacked together, holding it all together, and it's one giant solid structure. And there's looking at it from downstream, there's the Clarion, and here's the mouth of Clear Creek coming in right now. This gets rock and all of the soil excavation, as well as brush lifts coming down onto it. So we got that in, the wood's in, we're ready for dirt and coconut fabric. It's real helpful to have form boards up, if at all you can. We thought they were going to be a real hassle. They were a real hassle for my intern and my tech to put together this summer and then tote them there and get them installed. But my goodness, did they make a nice finished product. The Coir fabric, if you've never worked with it, it's awesome stuff. It's biodegradable, and natural seed will sprout up through it. So we put it in, we tacked it down with wedge stakes, have it draped over here. It's 13 feet wide and 85 feet long. We're filling it in here, and then once we get a section filled in, we wrap it over, put our native brush material in from the good folks at Ernst down in Meadville. They were awesome to work with. We got a mix of, say, half a dozen willows, a couple kinds of dogwoods, sycamores, 9-bark, and elderberry in there. This is July and August of this year, which is the exact wrong time to be soil bioengineering. But talking to them, they said, hey, we do these year round and see good success. So we're giving it a whirl. It's our best shot. I wouldn't do it in March on the Clarion. No. And also, so the Clarion and many of our other streams get every couple of years, they get these ice jams on them, right? So we threw in these ice deflector logs, just small pole timber that we could move around by hand to help, even if we're just protecting the stuff that's going to grow right behind them from some ice, it's going to make it that much better of a project and give it that much more of a jump on life. So we've got our first lift in, we're working on our second one, rolling the fabric out. If you're considering one of these projects, make sure you got enough help and labor. It's nice to have 6 or 8 people. Those Coir fabrics come in a big roll, and they're 300 pounds. And it's a little bit light for a machine to move, but it's nice if you have a couple of people to help you move them, lay them out. And then also there's the staking them in place that you got to do every 4 feet, you got to put stakes in to help hold them in place. But once you've got them in place, you fill it up with dirt, a little compaction if you need it, and then the last layer of brush, and then grading down onto it. We did have some hurdles, rain, especially early August. Hurricane Debbie made her way through Pennsylvania also, and she was actually kind to us. It just slowed us down on this. Thankfully, we had our stuff in before she arrived, and we weren't on the other side of the divide where she was much nastier. But those ice jams I was telling you about, every couple of years they come up on the floodplain and often slick down a riparian planting, especially if you got it in those tree tubes. So we wanted to add some floodplain roughness. And usually these, in the aquatic restoration world, you call this a lateral bar jam or a bar buddy. You can put these install root balls in a stream facing upstream, kind of like this. If my fist is the root ball and this is stream elevation, you bury it with flow coming at it and it'll make an island behind it. Pretty cool. But we installed them on the floodplain for roughness to help protect against ice and debris, because living stabilization is the crux of the project. It's a wild and scenic river. It has to be this way. Angle them upstream so they can fend off the ice, and we did 4 of them in this stretch. And they kind of start closer to the bank, and then they work their way out to kind of shuck it all out. When they're installed, that's a 25-foot root ball that's pretty much all buried except for the last few feet of it, and that's all you see sticking up above the ground. And then the slash and brush that we had to clear to get access for the site, we preloaded in front of those root balls as like pseudo-natural flood debris. And come mid-August, we're grinning. That's pretty beautiful. I'm standing on that big log jam. It's already working right here. It's slowed down. Got a couple extra root balls for where the water rolls off of it and hits the bank. Our seed's coming up through the coir, and we're all pretty happy. But, you know, I ordered my plant materials to arrive the first week of construction. We were there for 5 weeks. Some of those cuttings sat there for 4 weeks before they were put in. Less than ideal. I stored them in Clear Creek, so I kept them wet. But I know that I had more mortality than I would have liked. So we were just back there this past weekend with volunteers from the 3 local Trout Unlimited chapters who supported the project, doing some live staking. And I noticed that we did have, you know, in some places, there's a dogwood, there's a willow. Some places had like 12 inches worth of growth on the willows plus. So that was awesome to see. That being said, it has been a long journey to get, you know, this was just this spring, and here we are now. It's been a long journey to get here, and yeah, I'm thankful and happy with the project. My favorite part of a talk like this is the lessons learned. How did I get what made me scratch my head, you know? That unsuitable bench bottom is a big one, and communication is the takeaway. Talk with your permitters, talk with your regulatory agency, park staff. The park paid their staff, their operators and labor to help us with this project, so talking with them was awesome. I just mentioned the planting time. Again, that was talking with Ernst and saying, hey, you know, you might like the results you get. And then also we were back there with Trout Unlimited, and we did probably 600 or 800 plantings this past weekend, and we're going out this spring with the PA chapter of the Backcountry Hunters and Anglers to do even more plantings. I really want this project to succeed. Also, we started talking about this project in 2015, applied for a grant in 2019. COVID hits, we get money at the end of 2020. Things are delayed, prices increase. I'm still on budget for this project. Prices have doubled to quintupled, but those logs and root wads, I talked to a local logger that he thought he was giving me a deal at half the price that I'm used to normally paying for. Like, it was a good thing for him, you know, but it was like half the price. And also the fellow that donated the stone. You may have seen that pipeline that was sticking out of that bank and then wasn't. Boy, that racked my brain for a while, for years. And it was just not within the scope of the project to include that as like an official thing. But one day the excavator was out there and kind of accidentally nicked it, and we found out that it was dry. So I took a drill and I drilled a bunch of holes and confirmed that it was dry, and then we crimped it up and cut it off, and it's no longer an eyesore. It's several one calls. It's abandoned. Like, nobody wanted it. It's already broken on the other side of those islands. A good thing to get it out. Construction sequencing, we had to move some things around to, you know, for rain and stuff and weather. The river gods are the river gods, so you just kind of got to deal with them. And myself on track here. Like I mentioned, communication is key. I can't thank our partners enough, especially the Forest Service and Bob Gubernick being a mentor to me on the project, as well as Barron Environmental out of Boyers was our engineering firm on it. Great folks to work with. And there we go. Are there any questions?
So, said clearly that you wish this project will be successful. What does success look like to you?
In 5 years, you can canoe past it and not know I worked there. Out of live cutting plantings, I've seen up to 3 to 4 feet almost of growth in them in 1 year. That's if you put them in May or even the fall before, and they get a growing season's worth. I'm impressed that we put those sticks in August. That picture, I took that picture of the growing willow like right in there. And we've got 12 inches of growth. What we really need is root growth, which even the stakes that we cut Sunday, I would assume that they're starting to bud into there, and they're going to do that for as long as the ground's not frozen. So, yeah.
Have you, has the WBC looked into using, when I saw soil bioengineering, I thought, he's also going to talk about using fungi and mycelium in like the soil. Have the WBC thought about that in the restoration as a step prior to the plantings, basically using like spreading fungi and mycelium in the soil before the plantings as a way to encourage that root growth that you're talking about?
We've used root dip before. We do use root dip every time we do a riparian planting. As far as like a big broad application over a big soil area, we have not done, to my knowledge. But I am an amateur mushroom dork, and that sounds really cool.
Yeah, I just learned about it like a month ago when you back to the alligator. I was like, oh, I want to do that on the next restoration. So I was wondering if you have heard about it.
I've read some of the like Trad Cotter and Paul Stamets and a few of the other ones, and it sounds really cool, but I've not applied it yet.
I had a question about the disturbance. So obviously it's like already pretty disturbed, right, before you start remediation, but when you're remediating, I mean, that's still like a really like disturbed areas. And I know a lot of invasive species really like disturbed habitats. So how do you, like, are there certain steps that you take to prevent invasive plants from taking over the area that you're remediating?
Well, the big one in that area is stilt grass, and we're going to stay on it with the park and just be communicating with the park if something needs to happen. I know that there's emergency funding through DEP's Growing Greener program if we would need to. But right now, I mean, I've got down that northern Allegheny Plateau Province riparian mix down. I've got cover crop of winter wheat, which we had a flock of 20 wood ducks coming in and robbing seed, like immediately once we were done there. But yeah, it's just staying on it like that.
All right, thank you so much, Luke.
Thank you, Sean.
All right, we're going to keep things moving right along, and next we have Kelly Pierce with in-stream habitat improvement and monitoring updates in the Woodcock Creek watershed.
All right, welcome everybody. Luke, that was a really good background on what in-stream habitat improvements can look like. And so we'll learn a little bit more about that in a specific Woodcock Creek watershed, which is part of the French Creek watershed. My name's Kelly Pierce. I'm here representing a project through the Watershed Conservation Research Center. And this is not quite my specialty. I mostly study otters, but this is part of our watershed center's work. And so I'll try to answer questions to the best of my ability, but we just want to present this work. And so French Creek Watershed is a watershed that starts up in New York. It flows down to where the French Creek meets the Allegheny in Franklin. It's a very biodiverse watershed. It has over 80 species of fish, over 20 species of mussels, including state and endangered species. It's also, when we think about a watershed, right, we're not just interested in the water, the rivers, the creeks, but also the terrestrial land. And so we do have important terrestrial species, also like the spotted salamander. And of course, I have to show a picture of the river otter in the presentation, and they are a prevalent species in the French Creek watershed. But despite having really high biodiversity, French Creek is known for having good water quality. There are still stressors to the watershed. Erosion is one of those primary stressors. Luke mentioned that in his project, and that's mostly what our in-stream habitat improvement is really looking to reduce those solids, those sediments in the water that cause those things like turbidity,
Of course, in the French Creek, we're also concerned about invasive species like the round goby, harmful algae blooms, and runoff from agriculture. There, we're really thinking about those nutrients like nitrogen and phosphorus, which I'll also talk about today. So in terms of the project, the goal of this presentation is to talk about 3 in-stream habitat improvement projects that the Watershed Center has been involved with over the last 3 years. Ideally, these projects will reduce sediment loading downstream. So that is one of the primary goals of these in-stream habitat projects, to reduce sediment downstream. We also monitor these sites through biotic surveys pre and post restoration. So a lot of restoration goes on throughout the world. It's nearly $70 billion each year is put into restoration, but less than 10% of those restoration projects actually have long-term monitoring. And so we do these restoration projects and we think that they're doing what we want them to do, but there's not a lot of follow-up on if these projects reduce sediment, reduce nitrogen and phosphorus in the stream, increase fish habitat, increase macroinvertebrate diversity. And so part of what we want to do at the center is not only implement these projects, but also monitor these projects long-term. And so we do monitoring for fish and macroinvertebrates, and we also monitor for nitrates, phosphates, and then bacteria like E. coli and enterococci. These projects also provide on-site educational opportunities for Allegheny College students. We engage students in all aspects of the project, including the days that we do construction, which is a fun thing for students to run like a jackhammer, which they've probably never done before. And so it's providing these opportunities for students. So that's kind of one of our goals with these projects as well. So like I mentioned, this project takes place in the French Creek watershed, specifically the Woodcock Creek watershed, which is about 3/4 of the way down the French Creek. The Woodcock Creek itself is about 20 miles long. It covers about a 50 miles squared of area, which is about 32,000 acres. A lot of the land use in Woodcock Creek is forested, and then followed by agriculture, pasture and crop land use. But it is a relatively healthy watershed in terms of land use. It's not kind of overly, doesn't have high amounts of runoff that are like main concerns, where really erosion is the primary concern. And so we partnered with the Crawford County Conservation District, the Pennsylvania Fish and Boat Commission, who really provide the expertise in the design of these habitat restoration. Really what the watershed has done is help to fund these projects and then done the pre and post restoration research. But kind of those plans that Luke showed, those are not completed by us. They're completed by the Pennsylvania Fish and Boat Commission. And then Crawford County Conservation District is a really big partner in these areas. But similarly, we use these in-stream habitat restoration, commonly used areas like these modified mud sill cribbings, which are those logs covered with soil and then lots of these kind of heavy rocks. These, in contrast to the state park, were all done on private land as well. So I would say we probably have less restrictions on what we use, but we still do, of course, have those GP permits. And then we also have those root wad deflectors. That's an example of that, using these single log vein deflectors, which again help to slow down, redirect the flow. And then again, here's another example of those log framed stone deflectors. So these are the primary active in-stream habitat restoration techniques that were used among all 3 of these restoration projects. So here is our first. So we're going to go through each one of these projects. You'll see some before, during, and after construction. The first one is Craig Road, which is on the main stem of Woodcock Creek. It's our furthest downstream. So also note that this is a dammed area here. So this is all below the Woodcock Creek Dam. We'll talk about how that might be a little challenging when we are looking at our final results. But so here you can see, similarly, this landowner was losing lots and lots of land each year. You can see really high erosion on the bank. And again, this tree that was, of course, once covered in soil is now being exposed. This is actually a really popular, this landowner provides public fishing to his property as well. So it did have a little bit of that public interest. And so you can see, again, really high erosion that's going on. This is also downstream of a gravel bar. So you can see that gravel bar right there. This was during restoration, so you can see those log crib ceiling there. And then this is post-restoration, 2 months. So we similarly built out that bank, stabilized the bank, did plantings grasses, but also trees as well. Tealyho was our second site. This is on an unnamed tributary to Woodcock Creek. Also, what I want you to note here as we're walking through these images is these little drops represent all of our locations of our water sampling sites. So we have 11 sites throughout the watershed that we sampled, both upstream and downstream. So here again is that Tealyho site. This was on a private property. Really, really massive erosion. Interestingly, this unnamed tributary has generally low flow, but during high water events, it really gets extremely high flow. And you can see just this bank was eroding. They have lost over 15 feet over the last 7 or 8 years. And so really big concern. And the Conservation District was especially interested in this because they get really big buildup of sediment downstream of this site. So this was during restoration, similar type of techniques that are being used, building out that bank a little bit using those root wads. And here's a post-restoration site. So there was not a lot of filling in that was done here. Instead, really just trying to keep the high flow from hitting that bank. Our third site was Steinberg Park. This is right behind the Conservation District office. And so if you ever visit Woodcock Creek Lake State Park, or the park there, you can actually go and visit this site. It's another popular area for fishing, for just walking along. Again, severely eroding, especially during high storm events. You can see that erosion that's happening. And so this was a really high interest for the Conservation District because it's right there on their property. And this is where it is. So this one is kind of the closest one to the Woodcock Creek Dam in terms of where that's located. So here we are during, during that construction, and then this is what that after looks like of that site. So again, filled in rocks. Also, what you don't really see here is that we were able to put really large boulders in the middle of this creek. So it really, previously it was a very homogeneous habitat, and this restoration really kind of diversified that habitat. So we're kind of interested to see what that looks like. And so a little bit in terms of how we're monitoring these sites. Each site gets a pre and post restoration surveys during all seasons. So we go out and do surveys summer, fall, spring, winter, given the weather conditions are good. And these are kind of what we are looking for. So we do fish surveys using backpack electrofishing, macroinvertebrates, water chemistry like pH, DO. This year we installed hobo loggers for temperature and light in particular, and I'll talk a little bit about what that might look like into the future. We look for riparian habitat, water quality, and then a little bit of hydrology. So today I'm just going to briefly touch on those fish surveys, water quality, and temperature and light. So our water quality, we sample 11 sites, 11 locations in the French Creek watershed bi-weekly from June to October. We've done this for 3 consecutive years. Again, we selected sites upstream and downstream of each restoration site, again, Stainbrook, Tealy-Ho, and Craig Road. And then also where Woodcock Creek comes into the French Creek there at Caden's Landing, which is the French Creek Conservancy property. And then upstream, the Sagertown Boat Launch kind of as our control area for that French Creek. So these are collected bi-weekly from June to October. These samples are processed at the Regional Science Consortium for phosphates, nitrates, E. coli, and enterococci. This year, we did involve microbac for the phosphates and nitrates for those kinds of testing. So a little bit of what these preliminary sampling looks like for phosphates. So this is all sites just by date. So here's before our first restoration in June of 2022, the whole way down till September of 2024. So phosphates, we think about phosphates, they stick with the substrate. So they usually, phosphates sink to the bottom, really associated with that substrate. Tend to not see as much of fluctuation in phosphates as we do with nitrates, but we also want to be considerate of what those USGS, what the stream gauges look like to kind of match some peaks of that. So really we haven't seen pretty consistent, lower levels in 2023. These lines represent the times of our restoration. What I do want you to notice this year when we got our results back from microbac, I was like, what's happening? Our phosphates are like incredibly low. What's going on? And what we realized was that previously the analysis included the entire phosphate molecule, so including all those oxygens. And the other analysis does P as a product of that entire phosphate molecule. So it does make our interpreting a little bit challenging. So we're going to think through that a little bit more. We do have one high storm event there that's really associated with that high increase in phosphates. Again, high storm, high flow, pushing all those nutrients down into the watershed or into the stream. Similarly, no significant changes in nitrates at our 11 sampling sites over time. A similar thing we ran into with microbac testing for just nitrogen instead of the whole nitrate molecule. But you can see we have those fluctuations over time. Again, this is really a high water event that's probably can explain that. E. coli, pretty consistent, a few really high events, but this right here, the EPA recommends about 126 CFU per milliliter, and what our results are suggesting is that this watershed exceeds this on 49% of the sample days. So there are elevated levels of E. coli over these 30-day periods, which are recommended. And we have that same results with the fecal coliform as well. Really elevated throughout our study. This could be due, often we associate it with that like leaky sewages. There's really not a whole lot of development in Woodcock Creek. We think this might be because of the dam. There is lots of ducks, geese, wildlife on the watershed, so still a little bit more into why this might be happening. Finally, we're really interested in that sediment. We just have results right now for Craig. I just am presenting results from Craig Road before and after Tealy-Ho. We don't see much of a difference in terms of the substrate. So these are like visual things that we can see. In fact, we see a little bit of an increase there, which is really a good thing. And then in terms of bulk sediment deposition, higher bulk sediment means that there's more fine sediment that is, filtering in between those rocks. So we do see a bit of a decrease in that after, which is really not, it's not a significant difference. We're still kind of exploring this. Finally, looking at total suspended solids, high flow after some precipitation events. We're actually seeing an increase of this, which is not what we expect. We want this to go down. This could be because what we define as high flow is kind of nebulous. We need more of a quantitative assessment of this because we also are seeing that during base flow low conditions. And so I'll talk more about that in a little bit. And then in terms of fish richness, Primarily before Craig Road, we were seeing a lot of perch, a lot of minnows. After the fish community did change, even though we're seeing the same number of fish, mostly to perch and suckers. And at Tealyho, again, we saw dace as our primary species. Post restoration, we saw more stone rollers. But really no major changes in the fish communities. Really looking to do at least 5-year monitoring of these. Really, when you think about restoration, it's a long-term process. And so that's why it's important to do these monitoring. Often we have delayed responses. We're not going to see something 2 weeks later. Also, the Woodcock Dam provides a little bit of confounding effects. And noting that the construction can also impact more sensitive species. When those heavy equipment are in there, it's kicking up lots of dust. In terms of what we're interested in the future, is we're trying to build a model now that uses these hobo loggers as a proxy for light. Light that's getting in, which we want to use as a proxy for this TSS data because it's really labor intensive to get TSS data. So I can talk a little bit more about that individually. Just want to recognize Richard King Mellon Foundation, the Three Rivers Quest provided funding for our hobo loggers, the Conservation District, Pennsylvania Fish and Boat, local contractors. These guys just do really amazing work in these really tight conditions, and at all the WCRC students that helped on the project. Thank you.
One quick question. Thank you so much.
Thank you.
All right, if I can find the mouse, we will go right into our next presentation. We have Pallas Athena Kane with the AquaGator autonomous underwater robot for water quality measurement of the northwestern Pennsylvania lakes.
How do I use the clicker? Sorry.
It's just, this will next, that's back.
okay.
The center is the laser.
Perfect, thank you.
Yep.
Hello, everybody. My name is Pallas Athena Kane, and I'm currently a senior at Allegheny College studying computer science and art science innovation. And today I'm going to be presenting to you a project that I've been a part of for about 2 years now called AquaGator. There's a nice clicker. And so just to jump into it, our goal with this project is really to automate tethered ROVs for water quality management of northwestern Pennsylvania lakes. And so this project was really only possible with Allegheny College and the Watershed Conservation Research Center. And we've really gotten some great feedback from the Crawford County Conservation District. So that's all the people that are really been involved with us doing this. And so really, what are we doing with these ROVs, these tethered ROVs? What does ROV even stand for? So ROV stands for remotely operated vehicles, and oftentimes those are used in place of like places where people can't really access it, like in space or underwater. And so that's what we're really doing here, is using ROVs in place of us to do depth measurements underwater to make that a lot more efficient process. And so we're monitoring pH, conductivity, dissolved oxygen reduction potential, temperature, common water quality measurement values, and then we're also tracking depth as we're going. So to kind of go a little bit deeper into the motivations of like, why are we doing this project? And so the big one that is here is mitigating labor. So currently the process to water quality management is kind of labor intensive. You have to probe it yourself, track the data, write it down. There's a lot of different steps, and that could be autonomized and made easier. And so that's what we're really thinking about, is the easier that we make this process, the more data that we can get out there. So, and that's kind of what this is. Data collection. We're thinking about data as collecting on our lakes. You know, we have some data on our lakes now, but can we get more over time and process that and visualize it? Can we make a system that can automatically visualize that data for you while in the field or afterwards? And so really thinking about that, and with that visualization of the data, what can we do with that data? Predictions for preventative care. So this is really a step after what I do, is kind of like thinking about how we can interpret that data. And finally, thinking about cost-effective design. This project's really meant to kind of be an affordable solution to the labor costs of water quality management. And so just to give you some background, here are some of the lakes in Crawford County here. This is Woodcock, we have Pymatuming, Tamarack,
Conneaut Lake. And so we've really only tested in Woodcock and Pymatuning so far. We have a lot of testing to do, but that's kind of where we're looking at is with these certain lakes. Okay, and so this slide, I kind of wanted to show the current processes in case you're unfamiliar. And so this picture number 5 here is of like a surface monitoring device. And so it's really good for getting those water quality values, but what can it not do? It can't go very deep. So you kind of get that surface level value, but what are you lacking? You can't go like 1, 2 meters down, 3 meters down. Okay, so then the picture next to it shows someone using a probe. And so manually sending that down and tracking, oh, it's at this depth, write that down, do that. And so that's what's going down on here. It's kind of that process of how we currently do this water quality monitoring. And then number 8, I really wanted to put this up here because when I was presenting at a different conference, someone had mentioned to me is like, why don't you just make a buoy? And really that kind of defeats the purpose of what we're doing here is we wanted something that you could pick up, move, and track different parts of the lake. You know, buoy isn't really meant to be moved around every day and go and track multiple places. So that's kind of what we're doing with this project is make something portable, something affordable, something to make things easier. So going on to the method here. So this is really just a method, a big process. So the way we built this is we started with making the frame, designing that, the control system, designing that, the sensor system, the display, and finally, the best part, in my opinion, the automation. So starting with the frame and how we built that and designed that, we went with an orthogonal design. Really, it's just like a cube shape. It's pretty compact, and it's easy to calculate the movements here. We use PVC, which is a pretty common material in underwater robotics. It's not only affordable, but it's very like you can manipulate it, change things. You know, I can take off these pool noodles, stuff like that, and change it around without having to spend tons of money. It's also pretty lightweight compared to like metal and stuff, and it lasts a pretty long time. And we also here have a buoyancy system. So as you can see, we have pool noodles. So that's part of our cost-effective solutions. We're thinking about how people can replicate this. And so pool noodles are a big part of it, and like making it so it's even on both sides and has neutral buoyancy is a really big, important part of like automating it so it doesn't float up, sink down. You need it to be neutral. And then going on to the control system. So here I have the 4 motors. You have 1, 2, 3, 4. And so each motor has the ability to go clockwise and counterclockwise based on the current that you give it. And so the range of the motion really includes surge, heave, yaw, and sway. And those are kind of complicated terms, but just to break it down, motors 3 and 4 are just your forward, backwards. Your motor 2 in the center here goes up and down. And then your yaw is this motor 1 that's kind of like here. And it kind of acts like a crab scoot, so you don't have to do big full rotations of the robot when you're surveying stuff. And so, but you can also do big sways with turning one motor on and one motor off on the sides. So continuing on with the process here, we have the motors are controlled by an Arduino in this big control box here. And so the idea is that there's a computer right in here, and what it does, and you can program it to turn motors on and off or so on. And so Arduinos are really used oftentimes in robotics because they're just so easy to prototype with and change and code and stuff like that. And so that's what we've been really working with this project. Very user-friendly kind of thing. And the control box has a joystick, and you can't see it in this picture, but we also have a video monitor. And the video monitor is very important for like our live feed kind of features. And so a cool thing that you can do is you can turn this into manual mode and drive it around and kind of use it as like an eye into the lakes and look in, kind of peer into what's going on down there and look at plant life and stuff like that. But we also have the automation option. So you can, you know, not use the joysticks and have it just go to specific depths and measure from there. And that's really what we've been kind of focusing on. While the manual mode is cool, we want to kind of focus on getting data. And so this is our sensor system, our lovely little sensor box here. And then it has all the values that we're tracking. So currently we have 5 different sensor types in this box. It's all controlled by a second one of these little Arduino computers. And so every time it takes a data point, it goes through each of the sensors and reads them continuously. And these sensors are connected via a really long tether back to our robot. And that's kind of the limiting factor of what we're working with here is like how long can it go out? well, it kind of limits on the sensor length of the tether and how long you kind of do that. Right now we're at 25 feet, which could be increased, but you have to realize the longer you make a tether of a sensor, the less accurate it gets. So, you know, you kind of have to go with that. So then finally, on this part, we have the display and data collection software. So this is something fun that has done this summer, is you can literally connect to your laptop and turn on this program and it will live graph all of the stuff that you're reading. And it does it for each of the different types of sensors. And so this is kind of not currently graphing, but you can see it will go like this over time. But you can also do aggregate graphs that take like the entire hour's worth of data if you want to look, or like however long, and just look at the entire thing over a day. And it kind of adds it together and makes an entire graph on that. And not only can you do it over time, but you can also do it over depth, which is really what we're interested in, is like, does the temperature change as we go down in a lake? Probably. So let's look at that. We also have heat maps, which display sort of like a color, and I'll show you in a second what that looks like. It's like a live visualization of what we're seeing in the lakes. You also can make a CSV file with this program. Really what that means is you can export it to Excel spreadsheets if you want to make your own graphs and do your own stuff with the data. We also do note-taking and analysis on this. I'll get into the analysis more, but basically it's going to look at what the current readings are if it's within a valuable range. And then finally, if you're not really comfortable with taking a laptop out into the lake, which I understand, we have an SD card option. So you can literally just have the data read and it will do that and put it on an SD card. So you can take it home. But really what we're thinking about is kind of like out in the field work. How can we limit that? Going out into the boat, going back home, going back out in the boat, going back home. If you just read it as you're out there and kind of see where those alerts are as you're out there, it kind of saves you some time and some labor. And so here's some example graphs. This is just data from like the pool, so don't really look into too much into what the values are here. But just to show you what a heat map kind of looks like for the program, you can choose the colors. This is for pH. So pH is getting higher as we're getting lower in depth, which is on the side here. And then we also have it over time. And so it's really interesting to see like the different color patterns you can get here. And then over here, we have a graph with the conductivity levels, and like over time, they're rising. So say you left the robot in the same spot for a day, maybe you'd see some sort of difference over time. And then down here, just the depth versus ORP level. So if you wanted to graph the level over depth, you can kind of look at it like that. So there's a lot of variety that you can choose. You can choose the X and Y axis and how you want to graph things and how you want to visualize it. And that's what we're really thinking about, is like, how can we make that process a bit easier? So this is the part that we've been really working on, is the automation, vertical movement. So we got some really good feedback that doing it in meters is really important. So going down 1 meter, 2 meter, 3 meter, and taking those values after a certain amount of time, so like 5 minutes at a depth, and looking at that and kind of seeing how that works. So we really have a program here that automates in meters and feet, and you can choose to maintain the depth for however long you want. And this is really good for the measurements over time. So something else that's been an outcome of this project has also been education. I've been really working with K through 12 programs and teaching underwater robotics, just really introducing STEM to students and just making them interested in thinking about how technology can serve as a solution for problems that we have in our environment. So elementary outreach, like literally tomorrow I'm going to work with middle schoolers on building these exact robots, these systems. So it's really fun, it's been awesome. The outcomes, we've improved automation accuracy. So a big thing that we were doing was the thing would just go past the barrier that you wanted. And so we have to now be a little bit more precise and slow down as we get to that current depth that you want. We've tested in Woodcock Lake, Pymatuning Lake, the Allegheny College pool. Really, we want to test more. I think that's where the point we're at, is we want to go out in the lakes more. We have a product. Now let's take it out and get the data and collect that. That's where we're at. And so we've also been sensor calibration. I think that's just a big thing. Everyone who's used sensors knows you got to calibrate it pretty often and make sure that they're accurate. So that's been a big part of this project. fixing the hardware, whatever. We have to have a sturdy product before we can actually trust it to go out in the lake. So that's been a big part of my job, is making sure it goes back in shape every time. And so finally, I wanted to put, we also have build instructions. So like I said, we really want this project to be replicatable, especially in places of need that are like looking for robots like this, or just solutions to water quality management. And so this robot was built for about $2,500, which is pretty affordable considering that over half of that was just the sensors. So, you know, I think we did a pretty good job with what it is. And you can also swap out the sensors, not to attach to the specific sensor brand. Okay, so here's some fun pictures from us testing the lake. Here's us at Woodcock when there was a bunch of algae in the water. And so we always have to make sure to rinse in between different uses. You don't want to like take the robot here and then go, yeah, it's not great. So you have to rinse it out. And that was us having a fun time with the algae stuff. This was us with the Crawford County Conservation District. We went out on the lake, there's Brian, and we were kind of hanging out and trying to see what we needed to do, and he was giving us some really good feedback on how we can automate it better to make it more useful. And that's where we got the idea to do it in meters instead of feet. So yeah, future work. We want to integrate AI analysis. Like I said, we have a bit of analysis, but it could be way better is if we get a bunch of outside data on like, I can imagine it being algae bloom prediction or something along those lines. If you just feed an AI, here's before and after algae bloom, it can actually take that and predict algae bloom. So if we got a bunch of outside data, that would be really helpful. Otherwise, we'd have to collect our own, which is just time consuming. And then we're also thinking about adding radar, some sort of like outside of the robot, introducing that kind of stuff into the project so it can not only understand what's going on in the lake, what's going on outside the lake, because all these factors really contribute to what's going on. We also were thinking about the video capture system. How can we improve that? It's really cool that we have a live video, but it's not really doing anything. So can we do some sort of computer vision with that, or some sort of like literally recording it so you can look back at it later? And finally, just continuing our collaborations and getting feedback has really been an important part of this project. So, yeah, here's my works cited images, and thank you. Any questions? So far, time between a lot cleaner. But I mean, we haven't done a lot of testing out in the field. And like I was saying, that's kind of where we're at with this project. Is like literally taking it out and being like, oh, this is where it's good, this is where it's bad, this is where it's doing well under pressure. But I would say that we've had better time at time consuming than we have Woodcock. But I think it's also Woodcock was literally having algae bloom like this summer, and that's when we went out. So we had to find data there. Yeah.
So I know earlier you mentioned that the longer this cover is, the less accurate the data is. Why is that?
Yeah, so that's a great question. So that has to do with any sort of piece of wire has resistance, whether how small it is or not. So in electronics, we're really thinking about how we can limit that resistance. But these tethers are really long pieces of wire, basically. And so when they're sending information, there's a little bit of resistance from the wire itself that blocks the data from being completely accurate. And when I say I'm thinking like very small inaccuracies, like very small, but it is kind of something to be aware of when doing this kind of stuff. Yeah.
Will you test it at Presque at all, or perhaps at Presque Bay or anything like that?
I would love to. I think the main thing is we've been doing like still bodies of water and like kind of trying to keep away from seaweed because we have propellers like a boat. So yeah, I'd love to test it in other places. But yeah, I think that would definitely be a future kind of project thing. But just getting as much data as possible is really the project. Yeah. Really?
It's interesting that you brought up about the seaweed.
Yeah.
Because I've seen this happen before where we had, I think it was like environmental science class in like high school or something. We had, you know, a little propeller and it just got like all dumped up with the the weedy plants. And I guess I was just wondering like if there's, I don't know, like anything you've thought about in terms of like a solution for that.
Yes, to answer your question, definitely. I've been racking my brain on this for a while, to be honest, because I don't know if I can go back to it, but they are basically like mini boat propellers on the side of this robot. And so I can foresee a solution being similar to what people put on their boat propellers. It's like to protect them from seaweed. Obviously, it's not perfect, but like having like some sort of casing on the outside will prevent that tangling thing from happening. That you don't really have to dive in after the robot. That's the best part about it. Being tethered, I can pull it back up. Yeah, so just preventing the tangling, I think, is the biggest thing. Yeah.
So for the robot, what's the most, like, I guess, easily damaged part of it, other than the rotors and stuff? Because I didn't know if repairs would be very expensive if, let's say, the sensors was the most easily damaged, or if it's just using replacing PVC pipe to go.
Yeah, that's a good point. I haven't had to repair the sensors really at all. I haven't had to do anything with that. It's just recalibrating. They're pretty good. I would say I've done the most repairs on actually the box itself, like the control box, the electronics, lugging them around. I soldered every piece of this myself, and so with that, you kind of have little pieces of electronics that if you bounce them around too much, they fall out and do stuff. So I don't think the repairs are too expensive. I think we've had to replace one motor controller, which was about $20. So not bad exactly, but it's more just labor intensive. If I break something, I have to fix it, and that takes a bit of time, but that works.
We are just about out of
Thank
time,
you.
so we're going to keep moving on. Thank you so much.
Yeah, thank you.
All right, we are going to move into the final presentation for this afternoon's session. Where's the mouse? There it is. Next up, we have the Regional Science Consortium's aquatic biologist, Sarah Magian, with monitoring multiple cyanotoxins along the Pennsylvania coastline of Lake Erie.
You're on the other screen.
Oh, I didn't realize it changed that. That explains
We're
it.
extended again,
Gotcha.
so that people could actually.
Thank you.
You're welcome. Hello, everyone. I'm Sarah Magian. I am the Regional Science Consortium's aquatic biologist. You may have already seen me chairing other sessions and whatnot. But today I'm going to talk to you about one of the projects that I help manage here, and that is our cyanotoxin monitoring that we do. So we've been doing this HAB monitoring. It started down in 2014, and it has only grown since then, so it just keeps getting bigger and better, in my opinion. But so originally our goals are to develop a long-term monitoring program. I think we've done pretty well with that so far. We're 10 years in. We deliver our results as close to real time as we can to the public, and I'll go over that more in depth. We have developed a collaboration with veterinarians to identify cyanotoxin poisoning in pets, which I can also go a little bit more in depth with, and then create education and awareness about HABs. Do that all the time. One of our educators is in here right now, but that comes up a lot, educating. So, like I said, our sampling initiated in 2014. We do sample pretty much the entire PA coastline of Lake Erie. We collect our samples weekly, usually starting in May and running through October. Sometimes that varies based on funding. Sometimes it varies what cyanotoxins we can test for, which ones we can't. So I'll go over that too, some variability over the years, but generally speaking, weekly on Thursdays from May through October. We access these sites from the shoreline when we can, so wearing waders, or if it's a site like Dobbins Landing where you can't walk into the water there, we use what we call a swing sampler, which is on a stick, and you just reach down and you collect the water sample that way. We have a range, I say 27 to 42 sample sites because it tends to vary throughout the summer. So some of our sample sites are, say, with Edinburgh Lake, and they end their sampling sooner than we do. So some weeks we have less samples, some weeks we have more. We also work with Erie Waterworks, Northeast Water Authority. So that's why there's that variability. Those 27 sites are the ones that we always get. So those never vary because that's the ones that we are actually out grabbing every day. So our sites that we are collecting ourselves, these are the ones that you can see around the bay and around the peninsula. We also do have West County and East County sites that I'll get into as well. But on Presque State Park, we have 14 different sites. 6 of these are along the beaches. and 8 of them are bay sites. So where's my pickup? So we got our beaches starting down at Beach 1 West Extension. So this is even further west than your normal Beach 1 where the chairs are for the lifeguards. So basically like right next to the condos, if you guys know where those are. And then we go out to Beach 2, which is Zone 6. Beach 6 is Zone 2. I didn't determine that. Don't get mad at me. Mill Road is our Zone 3. Beach 9 is our Zone 4, and then Beach 11 is our Zone 5. So you can see how they're pretty evenly spread out across the beaches. That is intentional. We also use those sites for our bacteria monitoring, so there's a lot of overlap there. And then our main access points along the bay, also pretty evenly spaced, as well as getting Horseshoe Pond. That's where the houseboats are. And then for the Presque Bay, like I say, like the bayfront side of things, we have an additional 5 sites. So we have the Erie Yacht Club. We get samples at Liberty Park, Dobbins, Mill Creek, and South Pier. You'll notice on here we also have Garrison Run and Cascade. We do not track for harmful algal blooms at those sites. They are not tested for cyanotoxins, but we do collect for bacteria there, just like E. coli and stuff. So that's why they're on here. So for our East County, we now have 5 sites in the East County. So we go from East Avenue Boat Launch all the way out to 20 Mile Creek. And then in our West County, Walnut Creek, Avonia Beach, and then Elk Creek is our furthest site to the west. So we have 4 different kits that we use to test for cyanotoxins. One of those kits is microcystins / nodularins, so these are contained in one kit together. We also test for cylindrospermopsin, anatoxin, and saxitoxin, specifically anatoxin A. These are your hepatotoxins, which is liver toxins, and these are your neurotoxins. So all of them also are dermatoxins, but gives you a brief idea there. And by the way, we only test for the toxin level. We don't identify the species of bacteria producing it yet, but I'll get to that. So, cyanotoxin analyses. We use gold standard ELISA test kits. Like I said, that first one there is a combination of microcystins nodularins. And for that kit, we also use something called quick lyse. So it's actual chemicals that you add to your samples to help lyse those cells. So we get the maximum possible concentration of toxin present. We have to lyse all of our samples now. They've actually changed that over the years. So some of these test kits originally didn't have to lyse the cells at all. And then over time, we are now lysing for every single test kit for every sample. The rest of them, though, we can freeze thaw them, which is my preferred method because you just stick all the test tubes in the freezer and take them out 3 times, you know, it's great. The quick lyse, it's faster though. It's just a little bit more operator intensive, but we get our results faster. And then, like I said, there's been a lot of variability in the frequency of sampling over the years, but it's usually only increased. And the only thing that will limit this really is funding, a little bit technician availability, but Sean and I are both trained on it. I've had interns in the past that can train on it. It is kind of a complicated testing. I don't know if any of you guys are familiar with ELISA test kits from Gold Standard. Has anyone used anything like that before? Oh, great. I should have brought one up here. I have demo kits in the back. But anyway, it's full of a bunch of different standards and different reagents that you add to it. Some of them only take 2 hours. Some of them take 5. And it's in a little 96 well plate. And if you make any mistake, you're kind of done for. It's not fixable at that point. But we just save samples and run them on the next one. It's fine. I want to explain real quick. The variability for anatoxin A, saxitoxin, and cylindrospermopsin for this year was because we had funding that went through the end of July, and then that funding was over. So after the end of July, we didn't have enough funding to continue to complete those on a weekly basis. So over the past 5 years, we've done a lot of testing. We analyze all of our samples in duplicate. So all these numbers here account for that. And you can see our number of sample sites has only increased over the years. Yeah, it's a lot of samples. And back in 2019, not every site we collected was analyzed for every toxin. They've all always been analyzed for microcystin, because that's the most common toxin in this area, or at least like the most prevalent, but they weren't always tested for all toxins. These are the advisory thresholds that we look for here to inform the public. So we look at the water threshold for dogs, because often dogs do drink the water as well as swim in it and everything else. And then we look at recreational levels for people and a recreational no contact advisory. So that's for all 4 toxins. You can see they're all very different. On my figures, I have the dog level marked. None of our numbers go above a human level. So you will not see any results that go above this recreational public health advisory. So we don't have to worry about that one, which is very good. But we do go above the dog level frequently. Sax toxin has the lowest limit at 0.02 parts per billion. That's a neurotoxin. So for microcystin, like I said, this is the most prevalent, so I have the most data on this one. Once again, there were no advisories preventing human recreation, so that's great. The only time I have been able to find levels high enough that humans should not be recreating in them is in the really nasty scums. I don't know if you guys have seen really nasty, harmful algal bloom scums. Yeah. Usually they look horrible. They kind of smell weird. Hopefully people aren't going in those anyway, but they're usually very localized, isolated areas, and they're not at our usual sample sites. They're usually kind of nearby. So sometimes I'll grab them if I have room in the plate, but we have a lot of samples now, so I don't really have room in the plate. But Zone 5, so that's beach 11. So you can see that's the one beach that isn't on this side of the peninsula. It's kind of isolated over here. That's probably why beach 11 sees the most exceedances. It also sees the most bacteria exceedances for us as well for E. coli. So did beach 11 get shut down this year for E. coli? Yeah. So beach 11, this is pretty common. But that's where we saw the majority of our microcystin exceedances. Once again, this green line is our dog level. Nothing for people, just for dogs. So for the bay side of Presque, these are all of our sites marked. It gets a little harder to tell things apart. I did split things into as many figures as I could to try to make it easier to see all of the sites and the results. But it gets a little trickier, but everything above that green line, once again, is a dog exceedance. So you can see early in the season, we were doing pretty well, and then it got pretty bad. The surprising one for me was our last sample date this year was September 26th. We didn't get to go into October this year for funding reasons. But Vista 3 actually had our highest results of the entire summer of all sites on our last week of sampling. So we do not know, unfortunately, if those toxin levels declined after that date, because this was our last day of sampling. But that was our highest result for the entire season this year, 3.45. But that human level is 8. So that's still well below the human level, but very bad for dogs. So this is the bayfront side. Once again, there's your dog level highlighted in green. And you can see the highest result was actually in Mill Creek on the bayfront side. So we actually sample that from within the wastewater treatment plant. We go in there to get to Mill Creek, and sometimes scums form in there. So I don't exactly know what happened, but for the most part, you don't see many exceedances in Mill Creek, but then it also had our highest toxin concentration for this year. For the East County, we only saw exceedances at East Avenue Boat Launch and Lake Cliff Boat Launch. So those are both the furthest to the west of our East County sites. Farther out here, we did not have any dog exceedances. So that was nice. And then we had no exceedances at Elk or Walnut Creeks. That was the same in 2023. So for 2 years now, we have not had a single dog exceedance in either of those creeks. Avonia Beach did, of course, give us 1 exceedance for the entire summer, but that's still not too bad. Now, saxitoxin. This is the one that kind of, I think, has surprised us in recent years. We did not think there was much saxitoxin present around this area. So when we started sampling, at most we were sampling this once a month, and we were not finding any advisories for it. So when we got funding to start sampling it every 2 weeks, then we were like, oh, wait, there's actually some issues here. And then we got funding to do everything every week for the entire summer. And that's when we really started to see that saxitoxin is more prevalent than maybe we expected in this area, and that is the neurotoxin. So you can see here for the bay side of the peninsula, we were pretty good until mid to late July. And then we had a whole spike here. And then we had another tiny one in September. Not too bad, but still, when the dog limit is only 0.02 and you have levels of up to 0.15, I think that says, it's really blurry. But yeah, that's where we get concerned about if an animal were to interact with that water, how that will affect them getting to a vet, things like that. This is the bayfront side. Once again, anytime it was detected over here, it was an exceedance level. Most of our sites. Still infrequent though. Thanks, Sean. So, a little bit in the end of May, but then mostly that same time period of late July, early August. East County, once again, only East Avenue boat launch and Lake Cliff boat launch. So that's consistent as well, as it was with Microsystem. This is my fun little map that I like to make for myself to help visualize every year. So at the start of the season, there were no exceedances, and that continued until we had our first exceedance pop up at Boaters Beach this year. That was on May 23rd. So that was our first dog exceedance, and that's from Microsystem. And then as you go throughout the summer, we saw 3 saxitoxins pop up. My East Avenue was a little cut off in the corner there from the screen, but 3 saxitoxin exceedances popped up. Then we're back to just Microsystems a week later, across the bay from each other. Erie Yacht Club, Liberty Park, and these are all about a week apart. These are all our sampling dates throughout the summer. Sometimes you'll see them change. We did not want to sample on the 4th of July this year. That would have been a nightmare. So we sampled on the 3rd of July. So you'll see those pop up. You'll see occasionally the East County pop in here. So our first one that starts to look a little crowded is the start of July. It's not too bad. It starts getting kind of bad as you get into mid-July. We have a saxitoxin pop back up at East Avenue. The rest are all microsystent. Watching them move around, see saxitoxin occasionally pop up. This is our one Avonia. That's the only time you'll see West County on this map. And then we had a ton of saxitoxins pop up all over the bay. Very interesting. That was August 8th. Then it kind of cleared up a little bit. They're moving around some more. See more saxitoxin pop up. They kind of come in groups for saxitoxin. Oh, and you see there's a little beach at the end there too. The beaches don't pop in too frequently, but occasionally get your beach exceedances. So our advisories for this year, we had 181 advisories for dogs across our sites. And for anatoxin, we actually did have 2 exceedances, but they were at none of the sites that I showed you. They were actually down in Edinburgh Lake. So that's why they're not on here. I had to limit my data some. It was way too much. But so those guys aren't on here. But then we had 31 saxitoxin exceedances. As you can see, that's not the most we've had in the summer, but we also were not able to sample as much as we normally would in a summer. So that is why. Still no cylindrous bromopsin. We've never found an exceedance level. It's never been an advisory. So that was 214 total exceedances for this year. You can compare that to years in the past. And then obviously the vast majority of our advisories are for microsystem still. So the way that we give this information out to the public is through our online map. So I'm actually the one who updates this map every time we finish our ELISA test. We go on, we immediately update this. So the green just means that area is safe, and then there's a little dog sign for if it's not safe for dogs. We do have one for people. It never gets posted because we never had human advisories, which is great. So no one ever sees that sign, but we do have one. So you can access that through our website or through the Erie County Department of Health. I also post it to our social media every week. I have it like auto post on a weekly basis. So this is what it looks like if you were to go online and click on it. So this was that Vista 3 one that was the highest result we had for the entire season. I decided to click on that one to show you guys, but you get some little information. The last date that the sample was taken will be on here, because this is what the map will actively look like. If you go on, this is what you'll see. So it's important that people know that that was last sampled in September. It's not like we're sampling it right now. So it says that, and that gives you information on the side. So these are the actual signs that get posted at the sample sites if there is an exceedant or an advisory in that area. We do not post those though. Those are up to the property managers of those sites. We cannot make them put out signs. So I email them all the results as soon as they're done, right when I update that public map, and it is up to them to make sure signage is posted at those sites. We also, as part of our education, we have the mobile hab lab. This is a little trailer we can bring around. It's really cute. It's covered in dogs to help people understand that these things can be harmful to their pets. So often people are like, why can't they just drink the lake water? And I'm like, well, there's a couple different reasons. Would you drink the lake water? You know, that kind of stuff. Some next steps for us. We're going to continue our weekly monitoring, hopefully for all 4 toxins, as long as we have funding to do that. That's always our goal. We still want to make a predictive model, so we're still hoping to do that. And then we'd like to start making comparisons with all of our other data. We have tons of water quality data. We fill out a whole data sheet every time we go out. We bring a water quality sonde with us. So we have a lot of things to compare it to. We just need the time to do it and have the data actually get processed. So maybe an intern in the future can help with that too. And then we're also going to incorporate a new software that uses an iolite microscope, and it's called Bloom Optics, but it actually utilizes AI. So you upload photos from a microscope slide. So you take a little water sample, put on a slide, you take pictures of what's on the slide, you upload it to the AI model, and it tells you what species of algae or cyanobacteria are present in your sample. So we might actually get species soon, which would be really cool, but we haven't been able to implement that yet. And we have so many sites that I don't know if we'll be able to implement all of them immediately, but we'll see. And thank you. Yes.
So, sorry, I have a couple. Is there anything that can be done to prevent the general like algae scum, or is that just like based on water flow and some places just?
Yeah, so what mostly contributes to harmful algal blooms is sunlight, calm water, and a lot of nutrients. So we can't really control the sun, so we gotta count that one out. Calm water, some people like lake managers will actually try to control, and they'll add like circulation devices into their small lakes. On the scale of the Bay and Lake Erie, that would not be an effective solution. So for us, that leaves us with the nutrient inflow. So that's mostly from fertilizers or anything that would contribute nitrogen and phosphorus to the water system. So a lot of stormwater runoff related things, but we also do have a lot of like farms in the area and fertilizers and all of that would contribute. So that's where we would like to tackle. And like education is a big part of that, just getting people to understand that that has that result, and maybe don't, I don't know, put fertilizer out on your lawn when it's going to thunderstorm in an hour. It's not going to help your lawn, and it's just going to all go away. But yeah, these organisms have been around for a really, really long time. They're like dinosaurs. So they're fine, they're normal, but we're feeding them way too much.
Yeah. The wastewater plant told us that we back in the dog down the storm drain is what the main involved with.
Having sampled the storm drains, that is very, very, very true. We were out there
2 to 3 times a week for an entire year, the storm drains and the litter booms. And there was never a time that we did not pull out at least one dog poop bag. And it was usually more than one.
Just leave it in my yard.
All right, well, that's.
That's the goal.
They put it in the box and then they walk by. They got it on the street. Oh my God. I couldn't find any great. No, I always said I needed to write it down.
Well, there you go. We need to start an initiative to educate people about throwing their poop.
We
down
need
the
to do
school
social media outreach or something.
There you go, yeah. There you go, new project.
Yeah, you say that like the project's kind of getting bigger and better each year, which is great because we need water. But what's like your end goal? What's the level that you want to operate at?
I think the next thing that I at least personally would like to really get going is that predictive model. Because you obviously need real-time data to help train a predictive model and then to compare it to see if it's being effective. So we're going to need to do this for many more years, but if we can get a predictive model that's as good as our E. coli predictive models that we have, then maybe we could finally back off on the real-time testing, just because it is so expensive and very labor-intensive. There's been weeks where I've done like 6 ELISAs in a row, and you lose your mind by the end of it. At least I do. Yeah, so it would be nice to be able to reduce that a little bit in the future, but that predictive model would be so helpful. Yeah. Maybe even like an automated robot to help us or something like that.
You ever try to spell the water quality between Walnut Creek and 20 Mile? Because they have the same advantage and they're on opposite sides. Obviously, like, hold on.
That would be interesting. We totally could. We have all the data sitting there. It's just fun to have more ideas on what to do with it. So like that's a pretty interesting one. That sounds like an intern approachable project. A lot of our stuff can be really intimidating. Our interns tend to be like the one season, and sometimes they'll return for multiple seasons. But that is an interesting idea. We have not done that yet. Any other questions? Yeah.
Do you know of any instance where dogs gotten sick?
Not?
Contacted you?
Yeah, so that, I should have talked more about the vet side of things. We did have a grant that funded getting the veterinarians involved. On the positive side of that, we did not have any samples we received from vets come back for cyanotropic. So that's really good in this area, but at the same time, I feel like, then we're a little bit like less sure if it's happening or not, but whenever we ran that project for a while, we either weren't getting samples back because there was no suspicion of it being a cyanotoxin in this area, or when it was, it came back as not being a cyanotoxin. That being said, if we look in other parts of the country or in the world, yes, dogs die from this in other parts of the country. So maybe it's our sign. Maybe it's just people not letting a dog drink water. There's so many different things that would contribute to that. But in this area, I don't personally know of any directly correlated. And this would affect other wildlife too. It gets in the tissues of fish and everything else. So.
If people eat those fish.
Yeah. That's an active area of research. Because originally, like years ago, they were like, oh, you'll be okay. And now they're like, maybe don't eat the fish. So, we'll see where that goes. That's one of the fun things to hear about at every conference we go to every year, is watching that slowly change over the years, where they're like, okay, we're not really sure, so like, just hold on. And then I'm sure there'll be like safe catch limits and stuff in the future as we get more information. Anything else? I've totally taken this over time. Sorry.
Thank you, Sarah. All right, that does conclude this session. We are going to take a short break until about 2:35, in which the final session will resume.
I lost the mouse.
Yeah.
Okay. For those who are just joining us, welcome to the Regional Science Consortium's 20th Annual Symposium. This is our final session of the day. We have 4 talks, and we're going to begin with Don Bezkowski's Litter in Waterways and Marine Debris Infrastructure. Don, thank you.
So I'm one of the older students here today. No, I'm actually retired. I retired from DEP 4 years ago, and people didn't want me to have fun, so they just kept offering me more jobs and taking up more of my time here. So, but this is a really worthwhile organization to work for. That's me. I used to work in law enforcement. That's my law enforcement look. Okay, they're smiling. I worked with the coastal program for a number of years, and I retired out of Harrisburg after running the coastal program for 8 years. And then I worked as a deputy conservation officer at the Fish and Boat Commission for 32 up here. That's just, I put that stuff in there for another presentation, but I graduated from Gannon in 1982, way before many of you were born. So that gives you an idea of how old I am. And there's Jeanette, who is the brains behind this operation. And we have many partners for what we've done here. Keep Pennsylvania Beautiful, that's a nonprofit organization that's really about litter prevention, litter education, Lakeshore Towing and Marine Services. So full disclosure, I work for them too. So it was good that in this case that we had a pretty good connection with them. Jeanette from the Regional Science Consortium, Erie Western Pennsylvania Port Authority. If anybody knows Julie Slomsky, we work together pretty regularly and very well. Gannon University, Sam Mason, and a bunch of other people from Gannon, and we use students from Gannon as interns to help us connect a lot of the dots here. City of Erie, County of Erie, Department of Planning and Economic Development. Audrey's here from County Planning, and Erie County Conservation District. Okay, so litter creates a bunch of challenges, especially when we see litter in Presque Bay all over the place. And there's a couple places where it really, really collects up off of Ordock Road, if you know where that's at. And over along the area at Presque State Park, in the Bay area where the monument is, Misery Bay area, it just kind of collects up in there. And there's a lot of trash that comes in from storm drains within the city. Not everything comes from storm drains in the city. Certainly, there's probably some litter that comes from boating and other places too. But a lot of it is transported by wind, water, and it's a continuing problem. If you've ever done a cleanup, if you've ever participated in any kind of a cleanup, whether it's coastal cleanup, whether it's PennDOT cleanup, you go there, you clean up. You can go back the next day, and it is just as crapped up as it was sometimes before. Doesn't that piss you off? I mean, it really does. So my goal is to try to turn our anger that we all have related to this into action, and get a variety of different people involved, because litter is it's really never going to go away. This is the type of society that we live in, but it's not something that we should accept either. It's something that we really need to continuously fight. Some of the most damaging marine debris to aquatic and terrestrial wildlife includes the smallest pieces and particles of litter. Cigarette butts, it's usually the most prolific type of waste that we pick up during cleanups. Macroplastics and food wrappers. Everything is one-time use, and it's that needs to change, but it's probably not going to change in my lifetime. The challenges: litter booms collect litter. The litter booms will collect litter, but they require maintenance. They require removal and storage for the winter months, personnel, time, workspace, requires travel, monitoring. Litter booms require an ATON permit. That's an aids to navigation permit from the Fish and Boat Commission. We can't just put a litter boom out in the water and just say, hey, try to avoid it or whatever. We have to get a permit for that. So we appreciate the hard work of these students that are out there doing this. The solution. So this is the litter boom that was constructed with floating. It's like kind of like an oil boom. If you've ever seen an oil boom that has a material on the outside of it that is sucks up petroleum products or anything floating on the surface that may be of an organic nature. So we're working with Lakeshore Towing, Keep Pennsylvania Beautiful, Regional Science Consortium. We have 2 of these litter booms located on the Lakeshore Towing campus. Do you know where Lakeshore Towing is? Are you familiar with where that's at? Right on State Street, just to the west of State Street. Well, they also have at least one of the marinas. It was called the Gem City Marina. So we have one of the litter booms right along State Street and one of the litter booms on the far west side of the campus there. So you can see that this litter boom has snow on it. So it was, we keep them out there as long as we can before everything ices over. And you can see that there's not much out here, but there's a whole lot of stuff that's being caught inside within that litter boom. So with the coordination of the Regional Science Consortium, using staff and university students, litter booms are monitored through weekly collection of litter and also during periods of rain and precipitation immediately after. So that kind of gives you an idea of this is State Street, Dobbins Landing. There's litter boom right here along State Street. The other one is a little bit further back on the campus of Lakeshore Towing. That's what the western litter boom looks like. Here is the outfall. This is the outfall from, I believe, Sassafras Street. And the idea is just to intercept anything that's floating. The litter boom it's a floating piece of, it looks like a tube, looks like a hot dog on the water. And then underneath the litter boom is a curtain that's probably 3 feet and a cable that holds it down so it doesn't float up. So we're catching everything within the first 2 to 3 feet that may be floating in the water. Then we have the eastern litter boom, which is this picture you're looking south. This picture you're looking to the west. It's kind of right along State Street. And we were able to, we had some people come up and say, what are those things? What are you guys doing here? Is there a lot of oil coming out of these catch basins? And so we were able to put these signs up that describe what this is, what's happening here, just from an educational standpoint. It allows people to maybe, not be afraid to ask a question, but it just provides that information to them up front. And that this is the main part. Help keep Presque Bay and Lake Erie beautiful and dispose of your trash properly. So don't throw your butts in my bay, in other words, we all have to be responsible. So we had a couple different field methods here. Booms were monitored 1 to 2 times a week and after storm events. We collected, or the Gannon interns collected air temperature, sky conditions, water clarity, water color, meteorological conditions, wind, humidity, rainfall, barometric pressure. And then they use the SON to determine water temperature, specific conductivity, dissolved oxygen, pH, turbidity, chlorophyll, blue-green algae. As we just saw about the blue-green algae, that type of material really is prevalent in a lot of areas that don't have much water movement. So and these are 2 areas that don't have much water movement. Methods, weather, runoff, water quality issues, and challenges. So I'm going to show you a little video here. See if it will work. So what should I do here? Just hit there we go. Okay. Now, the students are picking up litter behind the boom, and this is happening as they're picking up that litter. It's a discharge. It happened on November 8th of 2023, while this symposium was going on. We do have audio. So we'll just let this play out. So note to self, if you're participating in a litter cleanup, if you're participating in any type of a cleanup or any type of a activity outside, and you see this, neon signs should be going off. Like, something is not right here. This does not look right. If you have a camera, everybody has a camera on their phone, if you can identify the date, the time, and get a hold of the authorities that have jurisdiction over this, Pennsylvania DEP, Fish and Boat Commission, in this case, County Health Department, City of Erie Police Department. Somebody needs to be called about what's happening here, because this is an unpermitted discharge. And we believe it came from a construction, probably a construction vehicle that was cleaning out a concrete truck somewhere up in the city. So we found some interesting things happening with these areas that where a cleanup is taking place. Like, so the interns are grabbing stuff. They're grabbing types of materials that are out there. And one aspect of what's in the water was to run different types of bacteria tests to determine if there's bacteria there. So there are two of the main kinds, E. coli and Enterococcus. The E. coli is in the pink, and you can see these are colonies that are growing on a plate filled with, that has agar in it. And then the blue is Enterococcus. It's these. And these two say TNTC. Does anybody know what that means, TNTC? TNTC is not good, okay? Too numerous to count. So when you have too numerous to count, that means you probably don't want to be in that water. You probably want to wash your hands when you're done with the water. You definitely need gloves when you're picking up this type of material. So these are like neon signs that should be going off. If you're participating in any kind of cleanup, make sure you're wearing gloves. So some of the stuff that's picked up looks like salad here, because it is. It's a whole variety of different types of litter that's mixed in with different types of organic material. And when you take the salad part out, this is what you get. A whole lot of cigarette butts, a variety of other pieces of different types of plastic, foam. But this is kind of what it looks like when it's coming out. So the people that are doing this, it's not just like go in and pick out some butts and stuff. That's work to separate out all that stuff and to dry it out. So this thing is these litter booms are a pilot project. We did this to see what we were going to find. It's not a be all and end all. It's not meant to catch every piece of litter that's coming into Presque Isle Bay. It's to determine what may be coming in and gather some additional information here related to bacteria. So you can see some of the concentrations here, bacterial concentrations. This is from the west boom. This is from the boom that's furthest west that we really don't have access to. 42 samples, 31 below human swimming thresholds. But we did have a couple that were in that restriction level. Same thing on here, 3 swimming restriction level. And then over on the Enterococcus, the bottom line is, depending upon, we're seeing these concentrations. And even though it's below the swimming threshold, there's still bacteria in there. You should be wearing gloves. You should be washing your hands. You should be making sure that when you're picking litter, the litter seems to be acting as a substrate for bacteria. So keep that in mind, that just because it's in the water doesn't necessarily mean it's clean. Don't go to McDonald's right afterwards, in other words. Make sure you clean your hands up. Well, here we go. Litter collection 2023. The number one issue. I feel like I'm on that show. What is that? Where the Family Feud. The number one, cigarette butts, 37%. Number two, foam pieces for some reason. That's this right here. What type of foam were they? What was it? Styrofoam?
I think like coolers, like or big bucket coolers.
Yeah, it's kind of looking tiny. Sometimes the smaller stuff, like if it's like foam plates or cups, sometimes
Okay.
it's smaller like that, but other times it's big, like someone ripped up a cooler.
Okay.
Yeah.
Okay. Plastic pieces, styrofoam pieces, food wrappers, and then there's other stuff that gets caught too. You know, the normal characters that we see in litter. Now these are from 2023. Then we have litter results from 2024. Tobacco products, single-use food items and bags, miscellaneous, food items, hygiene products, fishing waste, and then plastic foam pieces. So I didn't know that foam was so popular, I guess, but I never knew that we would see that much. We're always seeing, anytime I go to a site, it's usually bottles, cans of food wrappers and straws, you know, and cigarette butts all over the place. So West Litter Boom, litter collection. So this is inside the boom right here. And it's tobacco products are in the blue. Single-use food wrappers and containers is the big thing. Now this is inside the litter boom. This is outside of the litter boom. So wind would typically blow that stuff back in. So that litter boom is actually acting as a barrier for litter to get kind of pushed upstream a little bit. East Litter Boom. This is the one right along State Street. Within the this is within the boom area, and tobacco products. A lot of smoking. There's a lot of construction going on. Maybe that was part of it. Same thing over here. A lot of construction going on. West Litter Boom. We tried to make a connection between turbidity and the amount of litter coming through, but we really couldn't do that. And you can see these are like a week apart, where the turbidity actually came up after. It was almost like a week after pieces of litter were collected. So we have a little bit of work to do from that standpoint. East Litter Boom, same way. Here we have high turbidity with little pieces of barely any litter. Same thing over here. We have litter being picked up at a high rate with no turbidity. So it's all kind of all over the place. We have a lot of work to do with that. Petroleum products were also found using this biofilm. 625, 629, that's my birthday for any reference, if anybody wants to have a card or anything. 716 and 720, there was a film of some type of petroleum product that was lighter than water in those areas. This is us last year, research, the 19th annual research symposium, and this was a poster that was produced that includes a lot of the information that I'm giving you right here today. We do a lot of outreach. Litter Boom, we had a press release, cigarette butt program. GAN and Give Day was involved here too with coastal cleanup. These are the conclusions that we have. Litter Booms transport runoff catch runoff from adjacent parking lots in specific areas. Storm drains and outflow pipes restrict what type of litter may be discharged. Greater diversity and quantity of litter was found within the booms compared to immediately outside the booms. The project demonstrated that litter booms were highly successful at containing small items of litter, but you know, it's a pilot project. The unexpected, it was unexpected to see a discharge. So we were able to go into the city. We never found the actual truck, but we did find some evidence of the area where the truck was washed out. Okay, future and sustainability. Pursuing an additional location along the shoreline Presque Bay for another litter boom. We're looking to work with the Erie Water Authority to place one at the foot of Walnut Street. Litter boom would be located there. I'm going to be meeting with the executive director next week to see if we can talk about what would be required to do that. And we're always seeking funding to support this type of project. And we continue to work with partners and support student projects. So the bottom line is, this is a partner-driven type of program. We need volunteers, we need partners, we thrive on that. I couldn't do this all by myself. I have a degree in biology, but most of the work that I've done in my career has been in planning and getting things kind of started like this. But if anybody needs any information, you need any information from me related to Keep Pennsylvania Beautiful, that's my address, that's my phone number. Jeanette knows how to get a hold of me. And if you do want to do any kind of a project at your school, or get a hold of me and we can talk more. But I really appreciate the partnership of Jeanette here in this room and everybody else, all the other partners, and I appreciate your time today. Any you folks have any questions? Yes, sir. By the Fish Commission?
It seems like more of a state problem than a care problem.
Yeah, they're probably, well, when I never gave people a break on a litter, if I found a litter case and was working with Fish Commission, they got hammered. This is the way it is. There's no excuse for that. I don't know what the stats are. I could find out for you from the Fish Commission. I know the Game Commission has authority to do that. DEP, it's kind of small potatoes for litter violations. It's primarily state police, city police, law enforcement agencies that would be doing that. I could check into that for you. Okay, sounds good. Yeah, thank you. Yes.
So, in your opinion, do you think that some of the yearly trash infrastructure might be at fault? Because for context, I live over on the east side, over by like the Elm Street Walmart and stuff.
Yeah.
And compared to like the Mill Creek areas, we don't have trash cans given to us. We have to buy those, right? But when our trash day comes, I, as someone who picks up litter around my neighborhood, just in general on my walks, there's always more litter after trash day because the guys will crush the trash cans.
Oh.
There's plastic everywhere.
Yeah.
They just leave trash on the street, and I'm wondering.
It's a housekeeping thing because they're trying to get done as quickly as they can. Yeah, my mother lives in the city too, and I've seen that with with some of the other trash. We'll go pick up the bins, and there's.
I don't want to blame the program or anything, but with like an increase in staffing, funding, help that. It's just a favorite. The answer is yes. Okay.
There you go.
Oh, love it.
I think there's an infrastructure problem with whenever you have, and I'm not pointing to anybody specific, but when you're given a mission you have 8 hours to pick up this amount of trash in this amount of area, you're really pushing it. And so if things are left behind, they're not going to come back and get it. So did you have any other?
They're paid for 8 hours, whether they do it in 5 or they do it in 10. So that adds to it as well.
Oh, yeah. Yeah, that's true.
The fact that they put it out, the short answer is yes, and I can check with you.
Yeah, and again, our goal is to keep it off the street, because we know what's going to happen once it's on the street. It's the next rain that's going to make its way, or the next wind that's going to make its way to a catch basin. And then we're going to be picking it up on Coastal Cleanup Day in September. And then, or the day after, because that's typically how it is. So, but don't give up. That's the bottom line here. This is a fight that's not going to go away. Don't be discouraged, because like I said, it turns people's anger into action a lot of times. So I've been doing this for 40 years and I'm still dealing with litter. It's just like my bread and butter, but it still pisses me off though, every day when I see it, because it's totally preventable. So any other questions? Well, yeah, yes.
I guess I'm just, I was really curious about the lag that you mentioned in between the spike in.
Turbidity and,
Yeah, how long was that lag, and can it be like explained by like potentially, I don't know, if it was like a stormwater event or something, would it be like organic, like, I don't know, like I'm thinking like algae blooms or something like that, because that,
Do you
does
have
that
any-
explain the lag? Or is
So
it-
the hope was that turbidity would be a surrogate for storm event, wind event, wave event, like all those things that could move litter around.
and then excessive litter coming out at the same time.
Yeah, so we were hoping to see a relationship between turbidity and litter, but we didn't. So then that's actually interesting. It makes it interesting, like why not, and maybe investigating that a little bit further or correlating it only to storm events, things like that. So it just leaves us with another question to look at the data differently. That what we expected is not what happened, you know.
Yeah, but we'll be following up, yes.
Two quick comments. Yes, there's a ton of hats down there. Horrible down there. Lots of scummy hats. But then also, I think the foam is because it floats so well. So litter booms are perfect for catching foam pieces.
Yes.
It's like the ideal way to get them, where some other things can sink potentially or be held down. I feel like foam.
And if you
Litter
go,
booms are perfect.
and if you go to that site that I was talking about on Ordock Road, this like set of railroad tracks that goes through there. You got to cut over the railroad tracks. You got to go down this long grassy area. I'm not encouraging you to do this, but it's grinding up plastics right in that area. It's making microplastics right in that area. But if you go through there and you look in the water, you can see all kinds of submerged litter. So after it gets crushed up and gets moved around and gets punctured and stuff, it's not floating anymore. It's out there in the open water. We can't put these blooms in the open water because they're just not going to survive. They need to be in an area that's kind of protected. So if we did put them out there, I did get a tip from a guy who used to be at the Coast Guard for 35 years, and he said to call the strike force because they have booms that are set up to be in open water, and they won't fail. So that's on my list of things to do, but that's probably going to be a costly effort too. And then we have a lot of boating traffic too. People want to get in some of these areas to fish. Unfortunately, the area where a lot of the litter is coming in on Ordock Road, you don't have to go too much further north, and it's like a walleye, or not a walleye, but a muskellunge habitat. People love fishing in that area, so we want to make sure that we don't want to get something that's going to affect too many boats and too many anglers either, right? And people recreating. Yes. Amber.
Implementation of these to give people the option to put their trash in a receptacle in like a hotspot fishing area or anything like that.
I'm not doing that. This is just like a pilot project just to see what we're going to get. We will be talking about different types of alternatives, but the problem is so much bigger than just one spot. We're collecting little bits and pieces. The bigger problem is out there. We're just trying to figure out whether litter booms are going to be effective in some of these areas, whether people are going to be angry because they're there or not there. So there's some social aspects to this too. So we're just trying to figure all of this out with this pilot project. Yeah, but certainly the last thing I want is litter coming in to the Bayer Lake. Yes.
Would contacting you be the best way to volunteer, or is there like
Oh, yeah, you can contact me. I work with Audrey, who's right behind you at the Erie County Planning Office. So you mean to participate in Coast to Clean? Yeah, yeah. Audrey, can you give her a card, and I'll give you a card too, and maybe we can, I appreciate any kind of help we can get. So, all right, well, thank you. I'm sorry I didn't eat your time.
Thank you, Don.
Yeah, thank you.
All right, up next from Erie Waterworks, we have two speakers, Katie Stopperon and Hannah Barava.
good job?
Oh, did you? I'm sorry.
Yep, that one. The one that's highlighted right now. Yep.
Sorry.
Thank you. Have to go. Let's make sure. Okay, yeah. All right, hi everyone. My name is Katie Stoffren, and I work for the DEP out of the Northwest Regional Office in Meadville, and I am the geologist for the Source Water Assessment and Protection Program. And today we're going to be talking about the Erie Waterworks Source Water Assessment and Protection Plan that we're currently working on. So it'll start off with me, and then Hannah will be talking about the Green Township Water Main Extension project, which not only was an incredible project, but also underscores the importance of source water protection. And what I'm going to be talking about is what the SWAT program is, like the history of it and what all it entails. And then this plan in particular is really unique, not only because Erie Waterworks serves over 220,000 people, but all their intakes are obviously in Lake Erie. So this makes it a very unique project when talking about methods, which we will jump into. And we're also going to talk about collaborations and community outreach, which has been very central to the planning of this project. So to jump into a brief history, in 1996, the Safe Drinking Water Act amendments required that public water systems in every state develop a program to assess the susceptibility to pollution for their sources. So the PA DEP SWAT program was born, and it is a voluntary community-based effort to protect the raw water quality of sources, being wells, springs, or in Erie Waterworks case, surface sources used by community public water supply systems. So very quickly, each of those three main pillars, it is voluntary, so community water systems aren't forced to participate in this program, though it is highly encouraged, of course. And then it is community-based. As you'll see on the next couple slides, the protection zones are very, very large, spanning miles and miles, and obviously each water system doesn't own all of that. So it's very important to be involved and educated. And then finally, like I mentioned, this is for community water systems, which very generally is a water system that provides water to 25 of the same people year round. So that can be as small as a mobile home park or as large as Erie Waterworks. And it's not for private sources as well. So if you live at a home where you just have your own well and it's not on city water, though we do have other resources for that if anyone's interested. So the plan itself, kind of diving into the plan, it's a scientific designation of protection areas. So for a surface water source, we delineate a zone A, B, and C, A being the closest, and then C being usually the extent of the watershed. And then it points out potential sources of contamination, which we refer to as PSOCs. And those are within those areas that have been delineated. And they're also ranked based on what they are and where they are. And then they say that every $1 spent in protection amounts to $27 in treatment. So this is very good news for community water systems trying to save money. And then disaster planning. And so we kind of dive into their emergency response plans with that. And then education and information for customers. So we provide guidance on ways to educate the community and customers, but we also provide educational pamphlets that can be given to the residents or customers that you are providing water to. And then the best part of all, this is completely free. So this is a program funded by the EPA, who then gives us the funding money at the DEP, and then we make these plans. So Erie Waterworks will not be paying a penny towards any of this, which is really nice. And then it is a 5-step process. Right now, we are kind of in a mixture between 1, 2, and 3. So we have began forming our steering committee, which is a diverse group. The more diverse, the better, because you want all different pillars of the community getting their input in. And then, I'll show it later. We have a big list so far of organizations that have agreed to participate. And then our engineering firm is determining the protection areas as we speak. And then based off of those, we're going to be able to identify, prioritize, and rank those potential sources of contamination. And then once the water system and the steering committee has seen all of that, that's when you're going to be able to choose management and protection strategies. And then think about the future a little bit. Like, how do we want to go about planning any new sources, or how do we want to keep the ones that we have intact? So this is an example of a water system that does have an intake in Lake Erie that we did a swap plan for. But as you can see, they also have a spring and 3 reservoirs. And this was done in 2019. So here's those protection areas I was telling you about. Zone A being the dark orange, closest to the intakes. And it's also based on some other factors like groundwater flow direction. And then it's really hard to see, but the light yellow is the zone B, and then the dark blue is the zone C, so that farthest away area. But you might notice that the Lake Erie intake was not delineated. So that is another factor that's making this project really unique, being that their intakes are all in Lake Erie. For the first time, we will be using the EPA Great Lakes delineation method, and it's very interesting and it's very geared towards Great Lakes, of course, and all of their unique factors. So it actually uses a formula that accounts for many factors with Great Lakes, including the waterways such as rivers that are contributing to the source area, as well as the watershed. And then from that, we're also going to be using the EPA Great Lakes susceptibility analysis. So instead of using regular point source and non-point source potential sources of contamination like roadways or gas stations, it's also going to be taking into account for erosion and turbidity, elevation, and just a few other things that are very unique to a Great Lake. And then the last part I really wanted to talk about today was the collaborations. So luckily, we've had very positive responses from a lot of different groups so far who want to work together on this project. Obviously, the Regional Science Consortium being one of them, which we're super pumped about. So essentially, they're going to be able to attend these different meetings that we have with EWW and talk about some ideas they may have on how they can help. And ultimately, the one water concept is really what the big idea is for this, because our priority obviously is drinking water, but the earth has one water, of course. So anything that has to do with water is going to be affecting each other. So it's really great to have all these different groups working together and talking about maybe problems and solutions. So that is about it from me. So now, oh yeah, that's my email if anyone wants to contact me, or if anyone's here who is part of an organization that would like to participate in this, please feel free to send me an email, as we would love to have you. And now I will pass it on to Hannah.
So I'm Hannah Brava, and I work with the Erie Waterworks. I am a project engineer there, and I will be discussing the Green Township Water Main extension that we did this past summer. So Erie Waterworks' mission is to guarantee a continuous, uninterrupted, reasonably priced supply of quality water to its customers, which assures public health while promoting regional stability and future development. This is done by providing drinking water from Lake Erie, and we treat that drinking water, or the Lake Erie water, in these 2 different water treatment plants. We have RSW, and we also have Chestnut Street Water Treatment Plant. RSW is more state-of-the-art. We have membrane filtration. It's very up-to-date, very up-to-code. There was just a bunch of renovations that we did to RSW in the past couple of years. On the opposite end, Chestnut is more of a traditional sand and gravel filtration system. It's a little bit more grandfathered in. This is where Big Bertha, the pump, used to be. We do run Chestnut every few times a year, a couple of times a year, mainly for permitting and emergency uses only. That being said, we are able to serve this highlighted portions, water with those two water treatment plants. That includes the city of Erie, several different townships, including Mill Creek, Harbor Creek, McCain, Lawrence Park, and portions of Grain and Summit townships. We also supply water to Wesleyville and McCain Borough, and we sell bulk water to Summit and Fairview townships as well. This makes us the second largest supplier of water in northwestern Pennsylvania by population. We currently have approximately 63,000 customers, comprised of almost 220,000 people. So here's a image of the Lake Erie watershed. Theoretically, we could serve water to anybody in this blue portion here. We are not that big yet, but maybe someday. In this area here, all the water feeds back into Lake Erie, which is why it's so important to try to protect Lake Erie, especially since we're taking that, treating it, and that's what we're drinking every day. So part of the system expansion, we focused on an area in Green Township. The Green Township supervisors reached out to us stating that there's a need for water in this area. This overall project is comprised of 3 different phases. Phase 1, it's hard to see, but it goes down Cane Hill Road, Morehouse Road, Hartman Road, and Kirsch Road, where there's an existing water system that Green Township was operating and maintaining, which kind of drove this whole phase and the project itself. Phase 2 is proposed that will continue from the intersection of Morehouse and Hartman intersection and then go up Route 8 underneath I-90 to Wager Road. And then phase 3 would just basically connect those 2 phases. So as an introduction to phase 1, there was a need for water in this area. Green Township and some of the residents in this area reached out to us stating that there's a need for water. There are several water wells that are privately owned that were running dry. As well, there have been several homeowners during this project that have called us saying they were using like swimming pools to wash their clothes. They were unable to wash laundry, take showers, do the dishes, water their lawns, especially like during the summer months when water usage is high. There is a sewer line that just went in through Green Township. We think that might be related to why the wells maybe aren't replenishing as fast as they once were. So this project is especially important because it will facilitate the water system expansion and consolidation of the Kirsch Road well system, also improving the quality of life of residents in this area by providing them potable drinking water from Lake Erie. Additionally, it will assess the needs of the local fire department because there were several fire hydrants installed throughout the alignment, and also providing greater water quality and quantity to homeowners. We were able to do this collectively with Green Township by identifying and pursuing potential funding opportunities and ultimately installing approximately 7,000 feet of 12-inch ductile iron water main. So these are some of the funding options that we were able to secure for phase 1. Erie Waterworks applied twice to the local share account LSA program from the DCED. We won the maximum grant amount of $1 million. Green Township also applied for their own COVID-19 H2O PA program, where they ultimately won $817,000. Green Township supervisors ultimately forwarded this money to Erie Waterworks to just kind of streamline the project management of the entire project, ultimately leading to a collective grant funding amount of $1,817,000. All of this money was used to support the consolidation of the current Kirsch Road well system. So everyone that already had like a connection to like the public water in Green Township didn't have to pay for anything. It included all of like the service line work and internal plumbing connections. This is some construction details for phase 1. The contractor was Pollard Land Services. They are from Girard, Pennsylvania. The contract value was higher than the grant amount. It was $2 million approximately. The contract is still ongoing. It started in June of this year, will end in March of 2025. They just completed substantial completion last month They're out there right now working as we speak, working on restoration processes. We're meeting tomorrow to do like our final walkthrough. And engineering and inspection was supplied by HRG, which is an engineering firm from Cranberry Township. Overall, we installed 7,600 feet of 12-inch ductile iron pipe, including 8 fire hydrants and 16 mainline valves. Ultimately, 44 customer connections were created, 16 of those being new customers and 28 of those being of the existing well system. These are a few images of the construction of the actual water main. Here you can see the trench being dug out and the pipe being installed. Here are fittings and the mainline valves and hydrants are being installed. This is the main line going underneath a few sewer crossings, and then this is called a sheep's foot roller, which is used to compact the ground once it is put in the trench. As for phase 2, it is proposed. We are currently in like the application process for phase 2, hoping to kind of kickstart the next step for this project. Phase 2 will ultimately bring water from Green Township and into Mill Creek Township through the Route 8 interchange or corridor. Ultimately, we're hoping that by providing water along this essential, critical roadway, it will promote the growth of future and existing businesses, as well as fostering intermunicipal and regional collaboration, continuing the water system expansion, and continuing to provide and promote the improvement of the quality of life of residents in this area. Overall, we're still looking at different alternatives for the provisions of public water in this area and collectively working to identify and pursue potential funding opportunities. Some of these opportunities for phase 2 so far have been the Erie County GAP funding program. Green Township supervisors so far have been awarded $74,000, which will support the design and survey needs from HRG. Erie Waterworks, as I mentioned briefly, we are currently in the process of submitting an application to the LSA grant for the maximum grant amount of $1 million. And I believe that pretty much wraps up Green Township. That brings you up to speed on where we're at today. Do you guys have any questions? Yes.
Why do you use iron instead of, like, is it cheaper than plastic or is it safer or something?
We use a lot of ductile iron pipe in our system. There's a lot of cast iron. We don't really use a lot of like PVC or plastic pipe in the system. I am not really sure who came up with that. It's just kind of what our standard that we stick to, just to make sure that everything, like that way we have all the same types of valves, fittings, stuff like that. Once we pick the material, we kind of stick with it.
So we're not supposed to thought of the material.
Exactly.
Cool.
Yes.
If you guys are using cast iron frequently, you have to worry about rust and like degradation of the pipes and stuff?
So cast iron isn't something that we're newly installing. It's usually something that's already been installed. Portions of our system have been dated back to like the 1800s. Like it's very old in some portions of the city. So as we come across main breaks and stuff, we are replacing everything with ductile iron pipe at this point in time. Yeah.
They still have wood pipes sometimes.
I don't know that we've had wood pipe in Erie, like the city of Erie, but I was just at a training event in Pittsburgh and they brought up wood pipe and someone there said that they found wood pipe within their water system.
Okay, from Gannon University, our next speaker is Dr. Sherry Mason. She's going to speak to us today about Project Neptune. Sounds pretty cool. This much.
Over there. Be over here.
Thank you.
All right. All right. So I'm Dr. Sherry Mason. I go by Sam, so feel free to call me Sam. I was appointed July 1st of this year as the inaugural director of Project Neptune at Gannon University. This is a water quality and economic revitalization initiative. I come into this as a plastic pollution researcher who spends a lot of time digging up litter, hence my comment to you. And if I have a chance at the very end, I'll tell you about something that's very specific to the question that you were asking and to the gentleman who just left. It's better that y'all are using iron than plastic. A number of plastic pollution organizations, and we have a call to our national government asking them, as we're replacing pipes, not to replace them with PVC. If in nothing else, just think about East Palestine, right, which happened, and that was vinyl chloride that was being shipped to make polyvinyl chloride, PVC, for pipes. So if I had any plastic that I could get rid of immediately, if like I was given a magic wand, PVC would be the plastic I got rid of first. Top, it's toxic, it's awful, for multiple reasons, which is not why we're here. So I'm going to get back to Project Neptune. So Neptune, I know, is spelled wrong, and that's because it's an acronym. It's a really bad acronym, but I'm going to tell you what it is anyway. So it stands for Nano and Polymer Technology for Water Networks of Erie. There you go. Now you know. What I do love about the title is this allusion to the Roman god Neptune, god of the seas, god of water, and his trident. And so that's what I'm using as kind of my talking point today, is the trident, which is the three prongs of Project Neptune. So this project is focused on measuring, mitigating, and manufacturing. And so what I wanted to tell you today, to talk to you about today, are these three prongs. I was going to start with what we're currently doing at Gannon University, our future kind of efforts, and where I see this project going over the next 5 to 10 years at least. So starting on that measurement front, you may be aware of the fact that Gannon University has a research vessel called the Environaut, which is currently not in the water, but Flagship Niagara League, I see Joe in the back, is going to help us fix that. But this is our research vessel that gets us out into the water in order to do the measurements that are so key in terms of mitigation. On the mitigation front, it would be remiss if I did not talk about our connection to the Regional Science Consortium. And Gannon's greenhouse that is now Regional Science Consortium greenhouse on Gannon property, but it's known as the Gannon Greenhouse, that has now been opened and was discussed yesterday at the corner of 4th and Myrtle. So this greenhouse is growing native plants to be used in mitigation efforts, most notably on Presque and their sand dune restoration efforts. And so this is really understanding that connection with what we do on land and how that can help to mitigate impacts to water quality. On the manufacturing front, about a year ago, we opened the Makerspace, the Center for Manufacturing and Technology in the IHAC building on 8th and Peach. This is a view of the Makerspace. If you've never had an opportunity to go up there, the next chance that you have, you should just pop in and take a look. If you're like me and going to Home Depot is your idea of Toys R Us, this is your place. You walk in there and you're just like, oh my God, whatever I've been doing in my life, forget it. I just want to stay here forever. And you can just build things to your heart's content. So this really gives us a place where, as if you have a student who has an idea for some kind of a mitigation tool, you can go in here and you can make a prototype. If you have an idea, actually I just collaborated with them. I've been contracted to do some sampling, and I needed to have 2 nets attached to each other and weighted so that one will sink when I put it into the water and one floats on the surface. And so I've got these engineers doing it for me. Right, so they can really help to complement the science that's happening through the engineering, as well as that prototype development. And they do all sorts of really interesting work in the community as well. So that just gives you an idea, kind of a taste of some of the stuff that's currently happening. Looking into the future, I mentioned that we have a research vessel. I want to grow our research vessel fleet. Do I want a submarine? Maybe. I'm not opposed to it. Just saying, it could be fun. So on that measurement front, really looking to expand our research vessel fleet over time. Looking at that measurement and mitigation, those pieces together. If you've heard anything about Project Neptune, you probably heard about what's happening in the library around what has been referred to as the Great Lakes Research and Education Center. So we do have a contract for about 3,300 square feet within the library to build this center. We believe that it connects well with stuff that's already happening in the library. The library staff does as well. So this center, which has been, like I said, it was originally called the Great Lakes Research and Education Center, and then they hired me. And literally on day one at 9 a.m., and I met with my boss, I said, one of the first things out of my mouth, how tied are we to that name? And she's just like, I don't know. I was like, because it's awful and you need to change it. And she's like, well, why? I was like, first of all, are we going to be up in Lake Superior, Lake Huron, Lake Michigan? Are we going to be in any lake other than Lake Erie? No. All right, then let's focus on Lake Erie. And also, we're an educational institution. Why is education second and not instead of being first? And so after having many conversations, we are changing the name to the Center for Lake Erie Education and Research, which is a much better acronym. What is the solution to water quality issues in Lake Erie? It's clear. There you go. So we are working towards establishing this center. So this is the 3,300 square feet area approximately that we're be occupying. And this is, I'm just going to walk you really quickly because I know I don't have that very much time, but I want to walk you through kind of our vision for this space. So we did hold some public comment sessions, and these were the images that we showed, and now we're moving towards the construction documents. You can see that these are old, and hence they have the old name. But when you first walk around the circulation deck, this is what you would see. This is what you would be faced with. So this is our interactive exhibit space. On the floor are the 5 Great Lakes, with Lake Erie on that raised section here, so that we're really pointing out how Lake Erie is special, and it's our important lake, but it's connected to this whole system. And that area also gives us a space to do some educational stuff. We have the north wall is this bookshelf where we have interactive, we envision having interactive exhibits combined with having spaces for the librarians to put books that are connected to those interactive exhibits. So really kind of making the connection between the library and what we're doing within this center. There you see that's the image I thought was going to come next, but there's our Lake Erie, and we have projectors so we can do all sorts, we can show all sorts of interesting information that's specific to Lake Erie within this raised bed. So we can be looking at, depth profiles, but also where are water intakes? How do the fish migrate? Where are harmful algal blooms? Why does it start in the Western Basin and they tend to move east? Things like that we can do on this interactive exhibit table. And then you can see, I think, in the back here, we have another interactive panel that's more focused on all 5 of the Great Lakes. So we're moving from the local to the regional to the global with our Science on a Sphere. So Science on a Sphere is produced by NOAA. There are 600 different interactive exhibits that are already part of this package when we purchase it. It's basically just a suspended white ball in a room with 4 cameras that shine on it. And then, like I said, you have those 600 interactive exhibits that are already part of the package. So it's a matter of training people, and then we can bring people in to learn. So we have stuff on climate change, migration, evolution, geology. There's all sorts of really interesting exhibits that are part of that. And you can see in that, there's our science on a sphere. You could see kind of glowing, we have a window to look into our laboratory space that's intended to be both an education and research lab. So that's here. And then one area that's kind of more off limits is the wet lab that's really intended for the scientific research. And I'm really excited to, talking with PAC Grant, really want to do some freshwater mussel stuff in this space. So that's what we're working towards. So quick glimpse into our center. And the idea over the next 5 years is to use that center and the strategic action plan that I've been writing recently to build towards this, the Lake Health Environmental Analysis Laboratory, Lake HEAL. So I love acronyms. If you're going to have an acronym, make it a good one. So the idea of this is to connect all three of these pillars, you know, the trident that is Project Neptune. And there's kind of what really sets this whole project apart from other research labs and education centers in the Great Lakes is that we have an explicit focus on plastic pollution. So we'll be looking at all water quality issues, but we stand ourselves apart in that this is a specific focus for the work that we're doing. And with that, I want to thank you all for your time. So, do I have a minute?
Yeah, you have a few minutes.
I have a few minutes. Okay, so this semester, in addition to the strategic action plan that I mentioned, that I'm trying to get done, I've been doing a lot of grant writing, right? Because like this is a new project, we need money. So I have submitted a $20 million community change grant to the EPA. And part of that grant is to give to every resident in the city of Erie a trash can. A recycling bin and a compost bin, because we're going to pull food compost out of the waste stream and we're going to start composting it, because yes, it is garbage night. That is leading to a lot of that because people put out garbage and it's bad, and the number one thing in your garbage, food. And we put it out at night, and what do we have around town? Critters. Lots and lots of critters. We have raccoons and skunks. My husband and I spent $500 caging skunks and taking them out from underneath. Apparently, we have like the Manhattan apartment underneath our shed. So they kept, like, we would take out a mom and her babies, and then another family would move in, and we moved them out. Literally, he was like, I normally charge by the skunk, but you've moved so many skunks, I'm just going to charge you a flat rate. And now we have bunnies. So, you know, whatever. I'll take the bunnies. But you have lots of critters, and so they dig open those bags, and then the trash goes blowing down the street. And so it's a real issue. And the guys are not going to pick it up because, one, it's the middle of the frickin' night, and even can you see it? You know, but two, they're not paid to do it. It's not their job, right? And so we need to containerize it. Yeah. So $20 million grant. We're going to get it. I already have the bottle of champagne, so it's, I mean, somebody just needs to call the EPA and tell them that they're giving me $20 million, and, you know, so. All right, so that's what I wanted to share with you. That's why I gave you my business card.
And thank you for doing that.
Yeah. And we have in there 2%, this is based on the recycling partnership, a 2% replacement rate every year for trash cans, because they do break. But if you mechanize the trucks and the guys aren't throwing them, they break less, which we also have in the grant, in addition to a reusable foodware system, which would cut down on all the styrofoam. So I'm basically solving all the world's problems. You're welcome. Yes, sir.
First of all, let me say, it's been a very hard start. You can only build that.
Yeah.
Knows exactly all the
I inherited that mess. They should have hired me about a year.
As a somewhat retired educator, obviously we want to get high school kids. And listen, one of the most important programs gathered that SAS emotions. They know about, knows all about SAS emotion. And so something like that, I think, would be fantastic to really get the high school kids. Because they won't go down this.
Yeah.
Somehow we have to go out and network out to the high schools, which I'm sure eventually when you get stuff.
The grants that I've been writing are specifically to bringing students to. So we have a RISE program, which is a reprisal of the Regional Summer School of Excellence, running it as a summer camp. In addition, we're creating what's called an Area M3 Challenge, which is environmental responsibility through innovation and education. It's kind of like a science fair, but I'll look at that. The motion.
Absolutely.
Yeah.
And one other follow-up question. Given the fact that late history, you see some synergy.
Oh, yeah, absolutely. I've applied to be on the board. Nobody knows who's on the board as of yet. It's still going through the system. I also have great collaborations with the Thunder Bay National Marine Sanctuary, and I'm going up there in January to have a wine night with my good friend and discuss. I mean, there's also like a movie thing going on, but I'm going up there and we're going to have discussions about so that I can understand more about what's happening there and how to bring it here. Yeah, absolutely. Collaborations is how we get this stuff done. So a big part of what, I mean, since, well, actually, as soon as I heard I got the job, I started sitting down and making, my boss was like, I don't need to know about this because it was 2 weeks before I was officially started, but, why not? So I started having those meetings about those partnerships because that's key. Yeah. So. Yes, sir.
I think you said 1.5 space of the library was already closed to the public anyway.
Yes. Yeah, I forgot to mention that here, but yeah, and that 3,300, I mean, there's a lot of controversy about us taking over space within the library, but half of the space that we're using for this center was not accessible to the general public anyway. So we actually have opened more of the space up to the general public by building this center. And the other kind of controversy is the supposed low, per square footage, the low rate, I'm going to put that in quotes. But all of this educational stuff that we're bringing as part of this is being provided to anybody who comes into the library. So they don't even have to be citizens here, right? They can be visitors, and it's all coming for free, right? Gannon's paying for that. Gannon's paying for me. Gannon's paying for my time to write these grants, right? We're providing the match for the grants. So, I mean, there's a lot that's being provided to the community and visitors to the community completely free, right? So you have to, I think, consider that when you're looking at what we're paying. Plus, I want to also add who else was willing to buy any space within the library.
Do you think it would, do you think doing maybe like a social media campaign for like kind of advertising that section of the library as like a third place would help bring more young people in there? Because people my age and younger, we have the option to go shopping. That's it. Like, there's not much else to do that doesn't actively cost money. And I wonder if having like better advertising for those facilities would be good in facilitating a third place in the community around the area.
Absolutely.
Because I lived here for a few years. I had no idea any of that was there.
Well, it's not there yet.
Oh, okay.
We're building it, like we're getting the construction documents now. And we have the demo permit. So the idea is that it will be open over the summer of 25. So it doesn't exist, but I do have the idea of a social media campaign, mostly because of the pushback. So I have this vision of, bear with me here, the god Neptune coming out of Lake Erie with his golden trident, which is being built for me right now by Metalheads USA. So I'm taking this seriously. And appointing the Golden Knight Victor, who is our mascot for Gannon University, with the honor of being a steward of Lake Erie. He's, I mean, Neptune himself is just really busy. You know, there's a lot of water out there. So he needs stewards, and Victor E. Knight is that. So that's video number 1. There you go. All right, I probably took up too much time. I got it. Thank you.
Okay, and for our last talk, they need no introduction, but we have Dr. Nars and Jen, are you joining her as well? And Jen and Seal. They're going to be talking about the greenhouse, supporting a greenhouse utilizing stormwater.
Is it on? Yeah. There, thank you. Do you want to introduce yourself before you start?
All right. Good afternoon, everyone. Thank you for staying for the end of this session. We appreciate it. So I'm Dr. Jeanette Schnard. I'm the Executive Director of the Regional Science Consortium. This is our 20th annual symposium, so it's a really exciting event for myself. And one of the projects that we wanted to talk about and share with you was the stormwater project that we received funding from PA DEP Growing Greener. And we were able to implement best management practices on this site at Gannon University. And so we're making the most of every drop and supporting a greenhouse utilizing stormwater. So impacts of stormwater, we have, water that during a storm event is running off of the land, down into roadways, down into these storm drains. And when we look at an urban environment like Gannon, where Gannon's campus is, there is a lot of impervious surfaces. So we have a lot of parking lots, we have a lot of roadways, sidewalks, buildings with roofs. There is a lot of green space too. I will give them credit for that, but they're just in that urban environment. So a lot of impervious surfaces, which means all of this water has to run off and go somewhere. And then just due to the fact of climate change happening, we're seeing more intense storm events, so more volume of water in a shorter period of time, which can really impact and overwhelm the infrastructure that exists. And so runoff in urban communities often carries litter, different pollutants. The pollutants could be, like we were talking about, the bacteria that kind of adheres to the litter, as well as nutrients from lawn fertilizers, and it all goes down and washes out into Lake Erie. And so looking at best management practices, some of the ones that we have proposed to implement on campus include removing impervious surfaces, rain barrels and rain cisterns, rain gardens, bioswales, storm drains, and a management plan. All right, so Gannon is located, we are over here at the kind of gateway Presque State Park. That red dot right there is where Gannon University is, so you can get a good look that it is in a very much an urban environment, but it is also close to Lake Erie, Presque Bay. And so the first phase or first deliverable that was already accomplished this year was the removal of impervious surfaces, and so we were able to remove the maintenance physical plant at Gannon University was able to remove the House of Prayer. So that blue house that you see there with the parking lot on the west side of the building was completely demolished, removed. It's located on West 4th Street, and it's 1,500 square feet that we were able to get rid of all that impervious surface. And now it looks like what you see right there, which is this big open brown space. But what we are going to do with that space is install rain gardens. So this was just recently demolished. So spring of 2025, we're working with Laird Associates Engineering. We have the drawings there for what the rain garden will look like. Jen is generating the plans to put in that rain garden. And so, this is just a basic schematic of what a rain garden does, what it looks like, but it's really to capture that rainwater and for the plants to absorb it, to slow down the volume or the velocity of the water as it's running across the land, and also to absorb pollutants and nutrients that might be coming through on that water.
And I'm just going to jump in real quick if you don't mind. And so if you're trying to squint down to see like the plant list on here, don't really pay attention to that because this is what the architect came up with. But we're kind of actually taking a more active role in the selection of the plant species. So just a
I think that's a good
sidebar.
point to note. Is sometimes the engineering firms give you this plant list. We really want to focus on native plants, so not incorporating any non-natives or invasives into it. And so with Jen's expertise, she's able to look at that and be like, maybe not these ones, and maybe these ones that we know work well for this region specifically. So greenhouse and irrigation.
So it's over to me already.
Yeah.
Okay. So, and for many of you, you already know me. I'm Jen Salem. I am the plant lab and greenhouse manager. I actually started at the consortium doing plant propagation, and that's what I still do today. But the cool thing is that now we have a new tool in our toolbox, I guess. So I'm really excited. If you haven't driven by to see the new facility that we have, the greenhouse is actually located right here. Of course, this is an old, probably Google map. On West 4th and Myrtle. It's between 3rd and 4th and Myrtle. And we are able to bring over all of our growing projects to this site. And so, not going to read every bullet point, but the takeaway here is that it is super important that we have gone from 324 square feet to over 1,500. So that expands our capabilities exponentially. I mean, it's just incredible to go from we have a very nice greenhouse here, but it really wasn't meant to provide the plants and the space for everything that we are now growing for. And I will speak very briefly on the next slide or two about our actual projects that go on in the greenhouse and what we're going to be growing in the Gannon greenhouse specifically. This is a state-of-the-art greenhouse. It's really nice because it provides us with a lot of flexibility with the space. Because the way that I'm envisioning it, it's not just a place for me to grow plants in, but we really would like to do some outreach and education at this site. And you'll see on other elements of the property that we're really building that in. So we'll have a lot of examples of best management practices for stormwater, use and mitigation and things like that, and things that homeowners can take away from our site too. So.
And just to add, we did receive funding from Erie Insurance for the greenhouse itself. However, then we needed a home for the greenhouse. And so when asking Dr. Amaneko and Dr. Ewing, any chance you want a greenhouse on Gannon's property, they jumped at the chance. They thought that was a great idea. And so a lot of thanks also to making it happen and the donations and funding through Gannon and through their grant office that was able to bring that money in, because it takes a lot to build a greenhouse in the middle of the city. There's a lot of permits and other things that were not anticipated. And so the project grew, but we're appreciative of all the partners that we had to make that happen, and had our ribbon cutting this summer.
End of August. So we haven't been in it very long, but next year will be the first year that I actually get to grow everything for all my projects from that facility, and that's so exciting. So lots and lots more plants. But we also employ a part-time work study from Gannon, which is wonderful because we have students that we're trying to incorporate into the greenhouse, as well as faculty eventually too. And again, this is like all very new, just opened at the end of August. So I'm still trying to feel out what the greenhouse is like. I get a lot of text alarms from it, and I'm playing around with its settings a little bit. But I've worked in a number of greenhouses, and they're all different. It's just like your house or your apartment. Sometimes you live in a place and it's always hot, and you can turn the furnace off and it's still hot, or vice versa, it's always cold. Greenhouses kind of operate the same way, where they're just a little finicky and they need some TLC and a little bit of time to figure out what they're like. So we also have a cistern, which is pretty self-explanatory. It's going to catch water, rainwater, and we will eventually be able to use that water in the greenhouse and to do other irrigation. And so that's just another way that we're trying to capture and conserve some water. Oops, maybe I should go back here real quick. We have other elements to this, and so I will show you that, but I just wanted to give you a chance to. We have gutters on the greenhouse. I guess that would be a good, I should explain that first, right? That's how the water is getting into the cistern. And then we also, like I said, are incorporating some BMP or best management practices to the facility, like the site there, because we don't just have the greenhouse on the property, we also have an education demonstration house. And so that's going to be really conducive to have students and members of the public perhaps coming in to learn from us and see what's there. We will have a rain barrel. We have installed a pollinator garden, and we also have a native plant garden. And if you're saying, aren't those things the same thing? Kind of, but basically the native plant garden incorporates more native grasses. I guess those also help pollinators too, but we did differentiate the two just so people can take a look at multiple species that would go into each. And then we have also just, and you can tell because there's leaves in this picture, and all the plants are starting to go dormant, just put in a rain garden. It's kind of in the back of the property, so from 4th Street, you really don't see it when you drive by. It also sits kind of in a low spot, which makes sense. It's rain garden. And that is planted with native grasses. There's some carex and juncus in there. A lot of it was propagated in-house by us. And then we brought in a few really nice native plant species for that area. It's pretty large. And we also have this bioswale that is connected to it. And again, this is also probably impossible to see unless you come right onto the property, because this sits behind the education building, and then it does drain into the rain garden. It's kind of a cool element because it has like some hardscaping features with the rocks, but then, and you really can't tell in this picture, it's interplanted with little blue stem, and if you know little blue stem, that's an awesome native grass, and that's going to look so cool when that fills in. So, and then again, like I alluded to before, we have a lot of projects that we grow in the greenhouse. So the big one is our wetland restoration project that we've been doing, I think, since 2016 with the plant propagation part of it. So it's been going on for quite some time. And we will continue that project next, like I said, next year. We are starting a dune restoration project on Beach 8. So I've gone from growing wetland plants to now figuring out what dune species are like and how to grow those. We have the Regional Science Consortium Native Plant Sale, which is our annual get all the native plants out to the public kind of effort. And then the organization I founded, Go Native Erie, we have plants that we donate to public green spaces, including universities like Gannon. And then our Go Native Erie Native Friendly Business Initiative, which is something that is also, that's a brand new initiative. And what we're trying to do with that is encourage businesses to, when they start replacing their existing landscape, to choose a native plant for that replacement instead of going back to like boxwood, privet, burning bush, and things like that. And so we'll be growing plants for that project in the greenhouse as well. So we actually might need more space. And then these are just a few more shots of it. Again, it's a beautiful structure. Dr. Mason had the sign in there. It kind of gives people an idea of what's going on, what a greenhouse does, and what's happening in there. And then this is a picture of the greenhouse interior. You can see the shade cloth in there. Lots and lots of space for plants. So that is so exciting. I can't wait to get in there in the spring. That's amazing. And then I don't know if you wanted to give the thank you or you want me to.
Yeah, we can thank Gannon University, like I had mentioned, for the funding, the space, and the support, and being part of Project Neptune, and that's very important to us. Pennsylvania DEP Growing Greener for the Stormwater Grant. It's a 3-year project, and we just started it, so we're only a couple months into it. The Titus and Titus Ecological Services, they helped with a lot of the planning, the rain garden, native garden, and pollinator garden. Jenna, she's our work study. She's doing a fantastic job, and she was also an intern with us this summer and Project Neptune. Any questions?
It's not like a big question, but what are the most important plants you're growing and also personal program?
That's a difficult question to answer. I'm going to say that it depends on what project I'm growing for. Like, for example, if it was for wetland, I would say we focus on plants that benefit pollinators and other wildlife. I really enjoy the caryxes because they are a challenge. But then as far as my favorite, I like what a lot of the mountain mints can do. So that's a pycnanthemum species plants. They're not like peppermint or spearmint. They're native mint species. Those are great pollinator magnets. I also love Diarvilla, or it's called dwarf bush honeysuckle. It's not an exotic honeysuckle. It's a native honeysuckle. And for cut flowers, so that also grow my own cut flowers home. I like purple coneflower. It has a lot of bloom time, really strong stem, butterflies. Awesome. Yeah.
So the Pennsylvania Sea Grant has completed their Choose Native initiative, and those books will be printed. It's a guide.
Yes.
So, and I know you've seen.
I've seen it.
If that's something that you could use in your native-friendly business initiative, we'd be happy to supply some copies.
Okay. No, that'd be great.
Yeah.
Yeah, that'd be wonderful. Thank you.
How many species of blue?
2. We do sandbar willow and black willow. I know. All right, what else you got? Yeah.
What's sort of the kind of local in that area? I kind of know it. Hard to gauge it down.
Oh, I got you.
Nighttime. What's sort of the reception there, local residents? I mean, the kids like, ooh, what's going on here? And they stop.
We've had a lot of students stop in. We've had a lot of Gannon staff stop in. I feel like there's a lot of curiosity about this,
right.
You know. And also, we have had neighbors walk in, which is really interesting. Sometimes it startles me. But again, I feel like there's a lot of curiosity, and the greenhouse is it's clear, but it's a polycarbonate, so you can't really, it's not like clear, like window glass clear. You can't see right through it. You can just see like lumps of green stuff. And so I feel like there is that desire to get in, and I feel like we do need to have an open house in the future. Again, I know we had the grand opening, but I feel like once we get going with all our stormwater management things, we need to invite people in again so we can check it out.
Thank you.
Yeah, thanks.
All right, well, that was our last presentation for today. For those who don't know, tomorrow we have a whole nother day of presentations. Refreshments starting at 8:30 tomorrow. So if you are free, you should come join us. Thank you for joining us, and that's it.